Hey there, fellow night owls and curious minds, drawn to the darkness beneath the waves. Tonight we're embarking on a journey into the most enigmatic, bone-chilling, and utterly bewildering mysteries that our planet's oceans have concealed from human eyes. From colossal creatures that defy scientific classification to vessels that dissolve into nothingness without warning or explanation. From submerged civilizations, lost to the crushing embrace of time, to sounds so profoundly disturbing, they've left the most hardened scientists questioning their sanity in the silent hours before dawn. The vast blue expanse that blankets our world spans over 70% of Earth's surface, yet humanity has barely scratched the surface, having explored less than 5% of what lies beneath those deceptively tranquil waters. This sobering reality leaves an entire universe lurking in perpetual darkness, a realm teeming with enigmas that would transform your most terrifying nightmares into comforting lullabies by comparison. Before we begin our descent into these lightless depths together, consider taking a moment to like this video and subscribe to our channel, but only if you genuinely find yourself drawn to these explorations of the unknown alongside me. I'd also love to know in the comments where you're listening from and what time the clock shows in your corner of the world. There's something profoundly connecting about knowing who else has gathered the courage to join our midnight expedition into the abyss. Now dim your lights, perhaps wrap yourself in something warm, and let's ease into tonight's exploration of the ocean's most jealously guarded secrets. When you conjure images of the ocean in your mind, perhaps you envision sun-drenched coastlines, rhythmic waves caressing golden shores, or possibly dolphins leaping joyfully through spray-crowned swells. But tonight, we're venturing somewhere altogether different, somewhere primal and untamed. We're journeying to realms where light is never penetrated, where water pressure would obliterate human flesh in mere milliseconds, and where life forms exist that evolution seems to have crafted during a particularly unsettling fever dream. The ocean isn't merely a vast body of water. It's a three-dimensional alien landscape that exists right here on our familiar planet, teeming with beings so bizarre they appear designed by cosmic forces, with a taste for the surreal. Imagine this: you're suspended on the ocean's surface during a windless night. The water stretches before you like polished obsidian, mirroring stars that shimmer faintly overhead. But beneath your vulnerable form, extending downward for miles upon unfathomable miles, lies an abyss so profound that if you somehow transplanted Mount Everest into certain oceanic trenches, its proud peak wouldn't even breach the water's surface. And within that perfect darkness, things are moving, things are hunting, things are waiting with patience measured in geological time. The ocean exists beyond the boundaries of human comfort or concern. It operates according to principles so foreign to our terrestrial minds that even our most sophisticated scientific instruments struggle to decode its ancient laws. In the deepest trenches, water pressure exceeds 1,000 times what you're experiencing in this moment. It would be equivalent to bearing the combined weight of 50 commercial aircraft pressing against every square inch of your fragile body. And yet, against all logical expectations, life not only persists there, it flourishes with disturbing abundance. Creatures that have evolved in perfect isolation from sunlight, from warmth, from the familiar cycles that govern surface existence, have carved out their niches in this realm of eternal midnight and bone-numbing cold. They've adapted to conditions so extreme they might as well inhabit an exoplanet circling a distant star. Some generate their own ghostly illumination, creating constellations of bioluminescence that pierce the absolute darkness like living stars. Others have evolved transparent bodies, drifting through black waters like specters from some half-forgotten nightmare. But what truly keeps marine biologists awake during the small hours is this unsettling truth: we continuously discover new organisms in these depths, new ecosystems, new anomalies that challenge our fundamental understanding of life's boundaries on Earth. Each deep-sea expedition returns with footage of beings that appear to have materialized from dimensions beyond our comprehension. And for each discovery that answers one question, 10 more mysteries emerge from the shadows. The ocean has maintained its secrets for billions of years, and it yields them reluctantly, jealously guarding its mysteries beneath miles of impenetrable water and crushing pressure. But tonight, we'll venture into that alien realm to explore some of the most spine-tingling, sleep-disrupting, utterly captivating enigmas concealed in the depths. Because if you believe you understand what inspires genuine fear, wait until you learn about what has been thriving in our planet's deepest oceanic trenches, directly beneath our unsuspecting feet since time immemorial. The truly disquieting realization: we've only begun to glimpse the edge of these abyssal secrets. Let's begin our odyssey in a location that sounds as though it were lifted directly from cosmic horror literature, the Mariana Trench. Situated in the western Pacific Ocean, this submarine canyon represents the deepest known section of Earth's oceans, descending more than 36,000 feet below sea level. To properly contextualize this staggering depth, Consider this: if you could somehow drain all water from the Mariana Trench and place Mount Everest within it, the mountain's legendary summit would still remain submerged beneath more than a mile of water. The Mariana Trench isn't merely deep, it's fundamentally alien to human experience. The pressure at its lowest point exceeds 16,000 pounds per square inch, a force so overwhelming it would compress a human body into something resembling a crushed aluminum can in milliseconds. Water at these depths contains dissolved carbon dioxide that creates carbonic acid, meaning the trench is essentially filled with a weak acid solution that would slowly dissolve exposed human skin. The temperature hovers just above freezing, creating an environment of perpetual, penetrating cold that would induce hypothermia in unprotected divers within minutes. And yet, against these impossible odds, life flourishes in forms that challenge our understanding of biological adaptation. In 2016, scientists recorded a ghostly, jellyfish-like creature floating through the darkness of the Mariana Trench at depths previously thought uninhabitable by complex organisms. Its translucent body pulsed with an otherworldly grace, tentacles trailing behind, like spectral ribbons as it navigated through water, pressurized enough to shatter submarine hulls. How does such delicate life withstand conditions that would destroy our most sophisticated deep-sea technology? The question remains unanswered, a mystery suspended in the crushing depths. But perhaps the most unsettling discovery made in the Mariana Trench wasn't visual but auditory, a sound so bizarre that researchers initially refused to believe it originated from any known marine creature. In 2015, hydrophones lowered into the trench captured what has since become known as the Western Pacific Biawang, a mechanical sounding call that begins with a metallic groan before transitioning into an ascending series of unearthly squeaks and moans. The sound bears an uncomfortable resemblance to something manufactured rather than biological, yet it emanates from one of Earth's most inaccessible natural environments. While scientists tentatively attribute the sound to a minke whale variant, its precise source remains unconfirmed, leaving us to wonder what exactly calls out from these lightless depths, with a voice that sounds more machine than animal. What communication requires such peculiar acoustics, and who or what is meant to receive these messages? Moving beyond the Mariana Trench, let's consider another oceanic phenomenon that has confounded mariners and scientists alike for centuries: the Bermuda Triangle. This infamous region of the North Atlantic Ocean, roughly bounded by Miami, Bermuda, and Puerto Rico, has allegedly claimed hundreds of ships and aircraft under circumstances that stretch the boundaries of rational explanation. While skeptics are quick to dismiss the area's reputation as mere superstition or statistical anomaly, the sheer volume of documented disappearances gives even hardened rationalists pause. In December 1945, 5 U.S. Navy TBM Avenger torpedo bombers vanished without trace during a routine training mission over the Bermuda Triangle, taking 14 experienced airmen with them. The aircraft that departed that day to search for the missing squadron, a Martin Mariner flying boat with 13 men aboard, also disappeared without explanation, compounding the mystery with an additional layer of inexplicable loss. What force could simultaneously compromise multiple aircraft operated by skilled military personnel during clear weather conditions? No wreckage, no oil slicks, no floating debris, no bodies, just complete and absolute absence, where moments before human beings had existed in machines weighing several tons each. Some theorists suggest sudden releases of methane gas from oceanic floor deposits could create areas of reduced water density, potentially causing ships to sink without warning. Others propose localized electromagnetic anomalies that might disrupt navigational equipment and communication devices, leaving vessels and aircraft effectively blindfolded in hostile waters. More esoteric explanations include underwater bases operated by non-human intelligences, temporal distortions that shift objects between different points in time, or gateways to parallel dimensions that occasionally open beneath unsuspecting travelers. While such exotic theories might initially sound absurd, they arise from a fundamental truth: conventional explanations fail to adequately account for the pattern of disappearances that continues to this day. In 2017, a private aircraft carrying 4 passengers vanished from radar near Eleuthera Island in the Bahamas, disappearing as completely as Flight 19 did 7 decades earlier. What whispers through the Bermuda Triangle's waters, calling vessels and aircraft into oblivion with such persistent hunger? The ocean keeps this secret locked in its depths, adding new mysteries faster than we can solve the old ones. Let's dive deeper now into one of the most unsettling sonic phenomena ever recorded in Earth's oceans: the bloop. In 1997, underwater hydrophones maintained by the National Oceanic and Atmospheric Administration, NOAA, captured an ultra-low frequency sound so powerful it was detected by sensors located more than 3,000 miles apart. The sound, a rapidly descending series of pulses that, when sped up to human hearing range, resembled a massive bubble rising through water, was unlike anything in NOAA's extensive catalog of known marine sounds. Most disturbing was the sound's incredible volume. Analysis indicated it was several times louder than the blue whale, previously considered the loudest animal on Earth. Whatever generated the bloop created a sound that, in terms of sheer acoustic energy, should have come from a creature vastly larger than any known to science. For years, this recording fed speculation about undiscovered megafauna lurking in unexplored ocean depths, creatures of such immense proportions they would make the blue whale seem diminutive by comparison. Scientists eventually attributed the bloop to the sound of ice fracturing and calving from Antarctic ice shelves, a process that can indeed generate extremely loud, low-frequency sounds. But doubts persist among some researchers, who note inconsistencies between the bloop's acoustic signature and typical ice calving events. The sound occurred in a region with minimal ice presence, and its particular frequency pattern differs subtly from documented ice movement recordings. What if something truly massive stirred briefly from ancient slumber, only to return to the lightless depths before human investigation could identify it? The ocean's vastness provides ample hiding space for creatures that might surface only once per century or millennium, leaving behind nothing but enigmatic acoustic footprints for puzzled scientists to analyze. Consider now the underwater ruins that dot our planet's continental shelves and deep ocean basins, submerged structures that challenge conventional archaeological timelines and suggest human civilization may be far older than our history books acknowledge. Off the coast of Japan's Yonaguni Island lies a massive underwater rock formation that bears such precise geometric angles and apparent architectural features that many researchers believe it represents the remnants of a prehistoric monument. Enormous flat terraces, perfectly straight walls, and what appear to be ceremonial platforms are carved into solid rock approximately 100 feet below current sea levels. Mainstream archaeology maintains these structures are natural formations, shaped by geological processes. Yet Japanese marine geologist Masaki Kimura, who has studied the site for decades, insists the formations show clear evidence of human modification, dating back at least 10,000 years. If Kimura is correct, Yonaguni represents evidence of an advanced maritime civilization that existed during the last ice age, when sea levels were significantly lower than today. Similar underwater structures have been discovered near India's Gulf of Cambay, where side-scan sonar has revealed rectilinear formations resembling city blocks spanning an area of approximately 5 miles. Dredged artifacts from the site include carved wooden pieces, pottery fragments, sections of walls, and human remains that have been carbon dated to approximately 9,500 years ago. This dating places the Gulf of Cambay ruins in the same general time frame as Göbekli Tepe in Turkey, currently recognized as one of the world's oldest monumental structures, yet the Cambay site appears far more extensive and complex. How could such advanced architectural knowledge exist millennia before the accepted timeline for the development of urban civilization? What cataclysm consigned these sprawling structures to the ocean floor, and what knowledge was lost when their builders disappeared beneath the advancing seas? Perhaps most famous among underwater ruins are the roads and structures of the Bimini Road, or Bimini Wall, a submerged rock formation near North Bimini Island in the Bahamas. This site consists of a nearly straight line of limestone blocks that appear deliberately placed to form a road or breakwater extending into deeper waters. Some researchers have connected this structure to Plato's descriptions of Atlantis, suggesting the Bimini Formation might represent the outermost ring of the legendary sunken city. While geological explanations exist for the Bimini Road's formation through natural beach rock fracturing, certain features, including apparent tool marks and seemingly intentional placement patterns, continue to fuel speculation about artificial origins. What if these submerged structures represent merely the highest points of much larger complexes, now buried beneath centuries of marine sediment? The ocean's preservative environment means that whatever lies beneath these sands remains potentially intact, waiting for more advanced archaeological techniques to reveal their secrets. These underwater ruins pose a profound question. What if human civilization has risen and fallen multiple times throughout Earth's history, with each collapse erasing nearly all evidence of what came before? The ocean floor may contain the answers, preserved in oxygen-poor sediments where decay occurs at glacial pace compared to terrestrial environments. How many civilizations might have flourished and disappeared, leaving behind only fragments for us to puzzle over as we assemble our incomplete understanding of human history? The ocean guards these potential revelations jealously, accessible only to those with technology and resources to explore its crushing depths. Let's shift our attention now to one of the most persistent maritime legends, the Kraken, a colossal octopus or squid capable of dragging entire ships beneath the waves. For centuries, mariners' accounts of tentacled monsters attacking vessels were dismissed as sailor superstitions or alcohol-fueled hallucinations. Yet in 1857, Danish naturalist Jan Peter Steenstrup demonstrated that these tales likely originated from encounters with very real creatures, giant squid of the genus Architeuthis. These enormous cephalopods can reach lengths exceeding 40 feet, with tentacles lined with powerful suction cups rimmed by sharp, serrated chitin rings. Their massive eyes, the largest in the animal kingdom at up to 10 inches in diameter, enable them to detect the faintest light in the oceanic abyss where they typically dwell. For nearly 150 years after Steenstrup's identification, giant squid remained almost mythical, known primarily through decomposing specimens washed ashore or found in the stomachs of sperm whales. It wasn't until 2004 that Japanese researchers captured the first photographs of a living giant squid in its natural deep-sea environment, and not until 2012 that video footage was obtained of this elusive creature. The animal's spectral appearance, pale white with piercing, almost human-like eyes, evokes something from cosmic horror literature rather than conventional zoology. But even more unsettling than Architeuth is its larger, more aggressive cousin, the colossal squid Messanicotuth hamiltoni, which possesses not just suckers but also sharp hooks on its tentacles for securing struggling prey. These hooks, combined with the largest beak of any squid species and a nervous system designed for lightning-fast attacks, make the colossal squid one of the most formidable predators in the deep ocean. Scientists estimate that colossal squid may reach weights exceeding 1,100 pounds, with total lengths potentially approaching 50 feet. Their hunting grounds lie primarily in the lightless depths of the Antarctic Ocean, where they engage in epic battles with their chief predator, the sperm whale. Evidence of these titanic struggles comes from the circular scars found on captured sperm whales, remnants of squid suckers that latched onto the mammalian hunters during desperate attempts to avoid predation. Some sperm whales bear hundreds of these scars, testament to a lifetime of combat against giant cephalopods in pitch-black waters, thousands of feet below the surface. What else might exist in those uncharted depths, perhaps even larger than the colossal squid, that has thus far evaded scientific documentation? The discovery of these real-life kraken raises an unsettling possibility. If sailors' accounts of giant squid proved accurate, despite centuries of scientific dismissal, what other dismissed maritime legends might contain kernels of truth? Reports of sea serpents, observed by credible witnesses, including military personnel and scientists, persist across maritime records from virtually every seafaring culture. In 1848, the crew and 437 passengers of the HMS Daedalus reported observing a sea serpent estimated at 60 feet long, with a head rising approximately 4 feet above the water surface. The creature reportedly maintained pace with the ship for nearly 20 minutes, giving multiple witnesses ample opportunity to observe its features. Captain Peter Macau's official report described an enormous serpent, with head and shoulders kept about 4 feet constantly above the surface of the sea, moving with such speed that it created a wake visible from the ship's deck. Could such sightings represent encounters with surviving prehistoric marine reptiles, perhaps descended from mosasaurs or plesiosaurs that somehow escaped the Cretaceous-Paleogene extinction event? While mainstream paleontology considers this virtually impossible, given the absence of intermediate fossil evidence across 66 million intervening years, the ocean's vastness provides ample hiding places where relict populations might persist undetected. After all, the coelacanth, a fish believed extinct for 65 million years, was discovered very much alive in 1938, forcing a significant revision of scientific understanding regarding survival of ancient lineages. What other living fossils might patrol the ocean's middle depths, occasionally rising to the surface to be glimpsed by startled human observers? The ocean's opacity to our technologies and its sheer scale make it the perfect refuge for creatures that prefer to remain beyond human knowledge. Speaking of creatures that defy conventional understanding, let's explore the phenomenon of globsters, unidentified organic masses that occasionally wash ashore on beaches worldwide. These decomposing masses often feature puzzling anatomical characteristics that resist immediate identification, fueling speculation about unknown marine organisms. The St. Augustine monster, discovered on Florida's coast in 1896, initially appeared to represent tissue from a gigantic octopus, unlike any known species. Analysis conducted in the 1990s eventually identified the mass as decomposed whale blubber, but questions persist about why the tissue structure differed so significantly from typical whale anatomy. Similar globsters have appeared on coastlines from Chile to New Zealand, often with tissue structures and apparent anatomical features that create temporary classification challenges for marine biologists. While decomposition processes can dramatically alter recognizable tissues, rendering familiar organisms nearly unidentifiable, some researchers question whether all globsters have received adequate scientific scrutiny before being dismissed as known species. In remote locations with limited access to sophisticated laboratory analysis, potentially significant specimens may be documented only through photographs or cursory examination before natural decay processes eliminate valuable evidence. How many genuinely novel organisms might have been prematurely categorized as decomposed, known species without thorough genetic analysis? The ocean continuously deposits its strange secrets on our shores, but our capacity to recognize genuine novelty depends entirely on the right observers being present at the right moment. Between human error, decomposition processes, and institutional skepticism toward anomalous findings, our knowledge filters may inadvertently screen out evidence of truly unknown marine life forms. Now let's plunge into one of the ocean's most enduring mysteries, the nature and origin of underwater sounds that defy conventional explanation. In 1997, the same year as the bloop recording, NOAA hydrophones captured another unexplained sound dubbed Julia, a 15-second rising tone that resembles an underwater rocket launch or the mournful cry of some massive creature. Unlike the bloop, Julia has never received a satisfactory natural explanation. Its acoustic signature matches neither geological events nor any known biological source. What generated this haunting call from the ocean depths, and why has it apparently never been repeated? Even more perplexing is the sound known as upsweep, first detected in 1991 and continuing intermittently ever since. This sound features a rapidly ascending series of tones that repeat in a predictable pattern for hours or sometimes days at a time. While some researchers suggest upsweep may result from underwater volcanic activity, its remarkable consistency and apparent seasonal variations align more closely with biological patterns than geological processes. Could upsweep represent the communal vocalizations of an unknown deep-sea species that gathers seasonally in the Pacific Ocean? If so, what manner of creature communicates with such mechanical precision, and why has it evaded visual detection despite decades of underwater exploration? Perhaps the most unsettling of all unexplained marine sounds is Slow Down, recorded in 1997, a descending tone lasting about 7 minutes that resembles an artificially generated signal progressively decreasing in frequency. The sound's name derives from its audio profile when accelerated to human hearing range. It literally sounds like something massive decelerating. No known natural process produces acoustic patterns matching Slowdown's precise frequency changes. Some fringe researchers have suggested the sound might represent the acoustic signature of a massive submersible craft of unknown origin entering the ocean from above, essentially the sound of something very large, moving from air to water while reducing velocity. While mainstream science understandably rejects such exotic explanations, the fact remains that Slow Down's acoustic properties align more closely with mechanical than biological or geological origins. These unexplained sounds remind us that the ocean remains Earth's greatest territory of mystery, a realm where our most sophisticated detection equipment sometimes captures evidence of phenomena that exist beyond our current classification systems. What calls from those lightless depths with voices that match neither known creatures nor familiar geological processes? The answers may be swimming through black waters at this very moment, unclassified and unobserved. Let's now explore one of the most visually striking oceanic mysteries, underwater light phenomena that defy conventional explanation. Submarine crews and deep-sea explorers occasionally report observing unexplained illumination at depths where sunlight cannot penetrate and in patterns inconsistent with known bioluminescent organisms. In 1963, the Bathyscaphe Trieste descended to the Mariana Trench's deepest point, where observers reported seeing a surprising amount of marine snow particles that reflected the vessel's lights, but also noted brief flashes of light that appeared and disappeared without apparent source. Similar observations have been reported by numerous deep-sea expeditions, describing lights that seem to activate in response to the presence of human vessels, sometimes appearing to move with purpose rather than drifting passively with currents. While many such sightings likely represent encounters with undocumented bioluminescent organisms, certain characteristics of these light phenomena, including their reported reactivity to human presence, suggest possible intelligence behind some observations. Could intelligent marine species, with bioluminescent capabilities, inhabit the ocean's middle depths, observing our rare intrusions into their domain with curiosity, mirroring our own? The ocean's vastness and our limited deep-sea observation capabilities make this possibility, however remote, impossible to conclusively dismiss. Consider the case of the USS Tripping submarine, which in 1971 allegedly photographed unidentified submerged objects emitting their own light while operating near Norway. The photographs, which surfaced decades later, appear to show disc-shaped craft entering or exiting the ocean while surrounded by unusual lighting effects. While skeptics reasonably question these images' authenticity and official context, submarine crews from various nations have reported similar observations throughout the Cold War and beyond. What technology, terrestrial or otherwise, might operate in deep ocean environments with illumination capabilities that outmatch our most advanced submersibles? The ocean's opacity to electromagnetic radiation makes it the perfect environment for concealing activities from surface observation, whether conducted by conventional human organizations or more exotic intelligences. Now let's examine one of the most legendary oceanic mysteries, the enduring enigma of the Mary Celeste. In December 1872, this merchant brigantine was discovered adrift between the Azores and Portugal, completely abandoned, yet in relatively good condition. The cargo remained largely intact, the crew's personal belongings were undisturbed, and a 6-month supply of food and water was still aboard. Only the ship's lifeboat was missing, along with navigation instruments and the ship's papers. Most puzzling of all, the last log entry showed nothing unusual, and the abandonment occurred during fair weather conditions with no indication of emergency. What could possibly compel an experienced captain and crew to abandon a seaworthy vessel in relatively calm seas, taking only minimal provisions and leaving behind their personal effects? Conventional explanations range from alcohol vapor explosions from the cargo ethanol, creating temporary panic, to waterspouts or rogue waves causing brief but intense fear. Yet none fully account for the crew's failure to return to the vessel once any immediate danger had passed. More unusual theories suggest encounters with enormous marine creatures that temporarily threaten the ship, or perhaps exposure to toxic natural gases rising from seafloor vents that induced hallucinations or irrational fear. The Mary Celeste crew was never found, their fate joining countless other mariners who entered the ocean's embrace and never returned to tell their tales. Similar ghost ship cases pepper maritime history, suggesting patterns that transcend coincidence or conventional explanation. The high-tech equivalent of the Mary Celeste incident occurred in 2007 when the catamaran Kaz II was discovered drifting off Australia's Great Barrier Reef with its engine running, food set on the table, and laptops still powered on, but its 3-man crew had vanished without trace. Modern safety equipment, radio communications, and GPS tracking did nothing to prevent another perfect maritime disappearance, more than a century after the Mary Celeste. What commonality links these incidents across time and technology levels, creating situations where experienced sailors abandon functional vessels without apparent cause? The ocean collects its human tribute according to patterns we have yet to decipher, leaving behind vessels as silent testimony to its inscrutable power. Let's descend once more to the ocean floor, where scientists have recently discovered a phenomenon that challenges our understanding of underwater ecosystems, brine pools, lakes of ultrasaline water that exist within the ocean itself. These underwater lakes feature their own shorelines, surfaces, and even waves, created by the density difference between normal seawater and the hypersaline solution that forms the lake. Organisms that fall into these brine pools face almost certain death, as the extreme salinity proves toxic to most marine life, effectively pickling anything unfortunate enough to enter. Yet specialized extremophile bacteria thrive within these hostile chemical environments, metabolizing methane and other compounds that would poison conventional organisms. Along the edges of these underwater lakes, bizarre ecosystems have developed where creatures literally live between worlds, adapted to exploit the chemical boundary between normal ocean water and toxic brine. Perhaps most unsettling about these brine pools is their resemblance to mythological concepts of underworld rivers, boundaries between life and death existing in lightless depths. Ancient mariners who spoke of deadly waters within the ocean itself weren't entirely wrong, they simply lacked the technological means to confirm their intuitions. What other ancient maritime legends might contain similar kernels of truth, awaiting verification by technologies we haven't yet developed? The ocean's depths may hold the physical manifestations of myths and legends passed down through generations of seafarers, their observations distorted by limited understanding, but fundamentally rooted in genuine encounters with ocean phenomena. As our exploration technologies improve, we may find ourselves increasingly confronted with the realization that our ancestors weren't simply inventing maritime dangers. They were documenting real encounters through the interpretive lenses available to their cultures. Consider now one of the most persistent patterns in maritime disappearances, the phenomenon of sailors vanishing from vessels without trace, often during calm conditions, and sometimes while observed by fellow crew members moments before their disappearance. In 2007, cruise ship passenger Jennifer Seitz apparently went overboard from the Norwegian Pearl near Cancun, Mexico, an event captured on the ship's security cameras. Yet despite immediate search and rescue operations, no trace of her body was ever recovered from waters that should have allowed for relatively easy retrieval. Similar cases occur with disturbing regularity across commercial shipping, cruise lines, and private vessels, often featuring circumstances where recovery should have been straightforward, yet no trace of the missing is ever found. What forces can make human bodies vanish so completely in environments where currents, temperatures, and biodensity should allow for at least partial recovery? Maritime folklore contains references to various oceanic entities that supposedly claim human victims, from Norwegian drag, animated corpses of those who died at sea, to Greek sirens luring sailors to watery graves. While modern minds immediately dismiss such legends as superstitious explanations for natural tragedies, the persistence of unexplained disappearances under controlled conditions raises uncomfortable questions. Could something within the ocean environment, whether biological, chemical, or physical, accelerate decomposition processes beyond expected rates under certain circumstances? Might undocumented scavenger species rapidly consume human remains in specific marine locales, explaining why bodies vanish so completely in some areas, but persist as expected in others? The ocean operates according to laws we've only partially codified, with localized phenomena potentially creating conditions where human remains disappear far more rapidly than conventional understanding would predict. Let's shift our attention to one of the most visually dramatic ocean mysteries, underwater crop circles, discovered off the coast of Japan. In 2013, underwater photographer Yoji Okada documented intricate geometric patterns on the seafloor near Fukushima at depths of about 80 feet. These perfectly formed circles, approximately 6 feet in diameter, and featuring complex radiating ridges, initially defied explanation. Subsequent investigation revealed their creator, the male pufferfish, which laboriously constructs these patterns by using its body to create precise furrows in the sandy bottom. The purpose of this remarkable behavior? Attracting females through what amounts to elaborate underwater art, the pufferfish's interpretation of a mating display. While science has identified the pufferfish as the artist behind these particular formations, similar geometric patterns have been discovered in other oceanic locations where no pufferfish species exists. Off the coast of Western Australia, perfectly circular depressions measuring up to 20 feet in diameter have been documented on the seafloor, with no conclusive explanation for their formation. These fairy circles of the sea feature characteristics inconsistent with known biological activities, suggesting either undocumented marine organisms or geological processes we've yet to understand. What other artistic expressions or geometric anomalies might exist on the vast and largely unmapped ocean floor? With less than 20% of the seafloor mapped at resolution comparable to terrestrial surveys, countless mysterious formations likely await discovery in the abyssal plains and continental shelves. Now let's examine one of the strangest living enigmas in our oceans, immortal jellyfish Turritopsis darni, a species that possesses the apparent ability to reverse its aging process and potentially live forever. When faced with starvation, physical damage, or environmental stress, these remarkable cnidarians can revert from their mature medusa form back to their juvenile polyp stage, essentially resetting their biological clock. This process can theoretically repeat indefinitely, allowing individual Turritopsis darnio to escape death from old age through cellular transdifferentiation, where specialized cells transform into different cell types. Scientists have observed this species reverting to its juvenile form and then maturing again multiple times in laboratory settings, confirming its biological immortality under ideal conditions. While predation and disease still claim these jellyfish in natural settings, their cellular mechanisms represent a form of immortality previously thought impossible in multicellular organisms. What evolutionary pressures could possibly select for biological immortality in a simple marine organism, while more complex creatures remain firmly bound by aging processes? The existence of immortal jellyfish suggests that death from aging may be neither inevitable nor necessary from an evolutionary perspective, raising profound questions about the nature of life cycles in Earth's oceans. If one marine species has developed a method to reset its biological clock, might others possess similar capabilities that remain undocumented? Could more complex marine organisms have developed partial age reversal mechanisms that extend their lifespans beyond conventional understanding? The ocean's evolutionary laboratory operates across vast timescales and environments, potentially producing adaptations that fundamentally challenge our understanding of life's boundaries. Let's dive deeper into truly anomalous ocean phenomena, underwater structures and formations that resist conventional geological or biological explanation. In 1968, denizens of Abyssal, Bangladesh, reported hearing what sounded like cannon fire emanating from the Bay of Bengal, a phenomenon known as the Abyssal guns that has occurred sporadically for centuries. Similar acoustic anomalies have been reported globally: mispuffers in Belgium, Lagani Bodi in Italy, Retumbos in the Philippines, and Seneca guns in North America. These sounds typically manifest as dull booms or deep rumbles emanating from the ocean, audible miles inland, with no visible source or associated seismic activity. While conventional explanations range from distant thunderstorms to gas escaping from seafloor sediments, the persistence of these sounds across centuries and their concentration in specific geographical areas suggest mechanisms beyond current scientific understanding. Could these acoustic phenomena represent the audible manifestation of tectonic stress building along fault lines before it registers on seismic equipment? Might they indicate large-scale methane releases from deep-sea clathrate deposits, potentially signaling concerning changes in ocean temperature? Or could they represent something more exotic, perhaps the acoustic signature of natural electromagnetic phenomena occurring in specific ocean regions due to unique mineral compositions or geological structures? The ocean transmits sound with remarkable efficiency across thousands of miles, potentially carrying acoustic evidence of processes occurring in depths beyond our observation capabilities. These mysterious booms may represent the audible edge of phenomena originating in regions of the ocean humans have never directly observed. Now let's explore one of the ocean's most perplexing hydrological mysteries: underwater rivers, complete with waterfalls, tributaries, and distinct chemical compositions flowing along the seafloor. In Mexico's Yucatan Peninsula, divers have documented extensive underwater river systems flowing through submarine caves, created by the interaction between freshwater and denser saltwater. These rivers feature distinct banks, overlying atmospheric boundaries where different water densities meet, and even fall in riverside vegetation in the form of specialized underwater organisms. Divers report the uncanny experience of flying above these underwater rivers, watching particulate matter flow along defined channels through otherwise clear water. The most dramatic of these formations occur where underwater rivers cascade over submarine cliffs, creating true underwater waterfalls where denser water falls through lighter water and visible curtains. Similar hydrodynamic systems exist throughout the world's oceans, most undocumented due to their location in deep or inaccessible waters. The largest known underwater river flows along the Black Sea floor, carrying water volumes comparable to many prominent terrestrial rivers, such as the Rhine or Seine. These submarine waterways transport nutrients, sediments, and distinct microbial communities through the ocean in patterns scientists are only beginning to map and understand. What other hydrological structures might exist in deep ocean environments, creating complex water systems that operate according to principles we've barely documented? Our conceptual framework for oceanic processes may be missing entire categories of hydrodynamic phenomena that influence global water chemistry, temperature regulation, and marine ecology. Let's turn our attention to the mysterious case of UVB-76, also known as the buzzer, a shortwave radio station that has broadcast a repeating buzz tone since at least 1982, occasionally interrupted by cryptic voice messages in Russian. While technically not an ocean mystery, its relevance becomes apparent when we consider that the signal's extraordinary broadcast power makes it detectable underwater for hundreds of miles. Submarine crews report receiving the buzzer's distinctive signal even at operational depths, suggesting its purpose may relate to submarine communication. The signal originates from Russia but has changed transmission locations several times over decades of continuous operation. Why maintain a powerful shortwave signal broadcasting seemingly meaningless buzz tones for over 40 years, unless the apparent buzzing contains encoded information meaningful to specific receivers? Some analysts suggest the buzzer serves as a dead hand system, an automated nuclear retaliation trigger that would activate Russian nuclear forces if regular communication channels were disrupted. Others propose it functions as a channel marker, reserving broadcast frequency for emergency communications while confirming operational status through its continuous transmission. But perhaps most intriguing is the possibility that the buzzer's primary audience isn't terrestrial at all, but submarine-based, a continuous communication channel with deep-sea vessels operating on extended missions beneath the waves. The ocean's electromagnetic opacity makes radio communication with submerged vessels extraordinarily difficult, requiring specialized frequencies and immense broadcast power. The buzzer's characteristics align perfectly with these requirements, suggesting its monotonous drone may represent the audible edge of a sophisticated underwater communication network that remains largely hidden from public understanding. Now let's explore one of the most visually spectacular ocean mysteries: underwater fire or submarine volcanic activity that appears to defy basic physics by burning beneath the waves. In shallow waters near Tonga, Yemen, and Iceland, underwater volcanic vents create the surreal spectacle of apparent flames flickering beneath the ocean surface. These submarine eruptions occur when superheated magma, reaching temperatures above 2,000 degrees Fahrenheit, contacts seawater, creating explosive steam expansion and incandescent mineral reactions that mimic combustion. Specialized organisms have evolved to thrive in these extreme environments, metabolizing toxic sulfur compounds and thriving in water temperatures that would cook conventional marine life. These hydrothermal vent communities represent one of Earth's most alien ecosystems, operating on chemical energy rather than sunlight and potentially resembling life that might exist on distant ocean-bearing moons like Europa or Enceladus. The most dramatic submarine volcanic features are champagne vents, where liquid carbon dioxide bubbles from the seafloor like endless pouring champagne. These vents create localized environments where normal ocean chemistry is completely altered, producing conditions that may resemble Earth's primordial seas during the planet's early development. Some scientists suggest these unusual chemical environments may have played crucial roles in the original development of life on Earth, providing energy gradients and chemical precursors necessary for the first organic molecules. Could similar processes be occurring on other worlds with liquid oceans, perhaps generating exotic forms of life based on fundamentally different biochemistry? The ocean's hydrothermal systems demonstrate that life finds niches in environments we once considered absolutely hostile, raising profound questions about where biological processes might emerge throughout our solar system and beyond. Let's shift to one of the most enduring navigation mysteries: oceanic dead spots where electronic equipment fails and compasses spin uselessly. Sailors have reported these anomalous zones for centuries, describing regions where navigational instruments malfunction, engines sputter or fail, and electronic communication becomes impossible. While skeptics attribute such accounts to equipment failure, user error, or exaggeration, the persistence of these reports across different vessels, crews, and time periods suggests genuine phenomena worthy of scientific investigation. In 2005, the NOAA research vessel Ron Brown documented instrument anomalies while passing through the Bermuda Triangle, including compass deviations and inconsistent electromagnetic readings. Similar effects have been reported by aircraft passing through the region, suggesting localized electromagnetic anomalies that affect both marine and aerial navigation systems. Some researchers propose these dead spots may result from localized geomagnetic anomalies caused by unique mineral deposits or geological formations on the ocean floor. Others suggest powerful natural electromagnetic phenomena similar to ball lightning might occasionally manifest in oceanic regions, creating temporary disruptions to electronic systems. More exotic theories propose interaction between seawater and certain geological formations might generate weak electromagnetic fields through electrochemical processes, essentially creating naturally occurring batteries beneath the waves. Could the ocean itself, under specific chemical and geological conditions, generate electromagnetic fields capable of disrupting human technology? Our increasing reliance on electronic navigation makes understanding these anomalous zones increasingly important, yet comprehensive scientific study remains minimal due to the sporadic and unpredictable nature of the phenomena. Now let's explore one of the ocean's most unsettling biological mysteries: the global decline in phytoplankton populations, which some studies suggest have decreased by approximately 40% since 1950. These microscopic marine plants generate an estimated 50 to 80% of Earth's oxygen through photosynthesis, while forming the foundation of oceanic food webs. Their accelerating disappearance represents not just an ecological crisis, but potentially an existential threat to oxygen-breathing life on our planet. What makes this decline particularly mysterious is its uneven distribution. Some ocean regions show minimal changes, while others have lost nearly 90% of historical phytoplankton populations. This patchy pattern suggests complex interaction between multiple factors rather than simple climate change effects, potentially including oceanic pollutants, changing current patterns, and disruptions to nutrient cycling we don't fully understand. Some researchers have documented unusual changes in phytoplankton behavior, including altered migration patterns and shifting reproduction cycles that defy conventional ecological models. These microscopic organisms appear to be responding to environmental signals our instruments haven't yet detected or our science hasn't properly interpreted. Could phytoplankton be reacting to subtle changes in Earth's geomagnetic field, responding to electromagnetic signals that precede more dramatic climate shifts? Might their decline represent an early warning system for oceanic changes that will manifest more visibly in coming decades? The ocean's smallest inhabitants may be telling us something crucial about our planet's future through their mysterious disappearance, if only we could properly decipher their message. Let's examine one of the most persistent patterns in oceanic mystery: the tendency for similar unexplained phenomena to cluster in specific geographical locations around our planet's oceans. Certain regions, including the Devil's Sea near Japan, the South Atlantic anomaly, and the infamous Bermuda Triangle, consistently generate higher rates of instrument anomalies, vessel disappearances, and unusual atmospheric phenomena than surrounding waters. These areas often share common geological features, including underwater mountain ranges, unusual seafloor topography, or proximity to tectonic boundaries. Many also demonstrate anomalous magnetic properties, with compass readings that deviate from expected values even when accounting for known variations in Earth's magnetic field. What properties might these regions share that could explain their apparent influence on human technology and maritime safety? Some researchers suggest these areas may represent thin spots in Earth's magnetic field, where the planet's natural electromagnetic shield against solar and cosmic radiation weakens. Others propose they might contain unusual concentrations of magnetic minerals or geological formations that generate localized electromagnetic effects. More speculative theories suggest these regions might represent areas where physical constants or laws operate slightly differently due to as yet undiscovered properties of spacetime itself. Could certain ocean regions actually represent areas where the fabric of reality itself operates according to slightly modified rules? While such propositions venture beyond conventional science, the clustering of anomalous events in specific oceanic locations continues to resist comprehensive explanation through standard models. Let's now consider one of the most dramatic visual ocean mysteries: Milky Seas, a phenomenon where vast areas of ocean surface, sometimes exceeding 6,000 square miles, glow with an eerie white or blue-white bioluminescence visible from orbit. Unlike typical marine bioluminescence, which manifests as brief flashes or sparkling patterns when water is disturbed, Milky Seas create continuous, uniform illumination that transforms night into twilight across enormous ocean regions. This phenomenon has been documented in maritime records for centuries, with the earliest reliable account appearing in Jules Verne's 20,000 Leagues Under the Sea, based on actual sailor reports. Modern satellite confirmation of Milky Seas began in 2005, when NASA instruments captured an event in the Indian Ocean that illuminated approximately 6,200 square miles of water surface for 3 consecutive nights. What biological or chemical processes could possibly generate bioluminescence on such massive scales, maintaining continuous light production rather than the brief flashes typical of most light-producing marine organisms? The leading scientific explanation attributes Milky Seas to luminous bacteria, Vibrio harviae, colonizing microalgae blooms, creating a biological light system operating on industrial scales. Yet questions remain about the triggering mechanisms that cause these bacteria to illuminate simultaneously across thousands of square miles, maintaining synchronization for multiple nights. Some researchers suggest atmospheric electrical phenomena might provide the triggering mechanism, perhaps through subtle changes in water surface charge during certain weather conditions. Others propose that pressure waves from seismic events might synchronize bacterial light production across vast areas through mechanical stimulation. These explanations remain speculative, as scientists have directly sampled active Milky Seas only once, during a 1985 research vessel encounter in the Arabian Sea. Perhaps most unsettling about Milky Seas is their apparent intelligence. Many observer reports describe the illumination responding to vessel movement, sometimes appearing to track ships or aircraft passing overhead. While likely representing the interaction between vessel wakes and bioluminescent organisms, these descriptions from experienced mariners suggest behavior patterns more complex than simple mechanical stimulation. Could communal bacterial colonies develop emergent properties that mimic intentional response to environmental stimuli? Might oceanic bioluminescence represent a form of communication between microorganisms operating on spatial and temporal scales we struggle to recognize as meaningful? The ocean's light shows may represent biological communication systems whose patterns and purposes remain entirely opaque to human understanding. Let's explore the puzzling phenomenon of rogue waves, enormous, isolated waves that appear without warning even in relatively calm seas, defying conventional wave physics. Prior to the first instrumental recording of a rogue wave in 1995, maritime accounts of walls of water appearing suddenly from otherwise manageable seas were generally dismissed as sailor exaggeration. That changed when instruments on the Dropner oil platform in the North Sea recorded a 26-meter, 85-foot wave appearing in a sea state where the significant wave height was only 12 meters, a statistical anomaly that should occur less than once in 10,000 years, according to prevailing wave models. Since then, multiple rogue waves have been instrumentally confirmed, forcing a fundamental reconsideration of ocean wave dynamics and risk modeling for maritime operations. What mechanisms create these marine monsters that defy conventional understanding of how water should behave? Current research suggests rogue waves may form through several distinct processes, including constructive interference, where multiple wave trains intersect, and nonlinear focusing mechanisms that concentrate energy from surrounding waters. Other theories propose interaction between waves and ocean currents, where energy becomes concentrated as waves encounter opposing water flows. Perhaps most intriguing is the growing evidence that rogue waves may result from soliton formation, self-reinforcing solitary wave packets that maintain their shape and velocity while propagating through water with minimal energy loss. These nonlinear wave structures behave more like particles than conventional waves, potentially explaining how rogue waves maintain their height and energy across significant distances. The mathematics describing these phenomena connect to some of the most esoteric areas of physics, including chaos theory and quantum mechanics, suggesting our oceans may demonstrate quantum-like properties at macroscopic scales. Particularly disturbing is the growing evidence that rogue waves may be more common than previously believed, with satellite data suggesting these killers may occur multiple times daily across the global ocean. Their sudden formation and tremendous destructive power make them prime suspects in many unexplained vessel disappearances, particularly those occurring during otherwise moderate weather conditions. Could these hydrodynamic anomalies explain cases where vessels vanish without distress calls, their crews having no time to react before catastrophic structural failure occurs? The ocean surface occasionally behaves according to mathematical principles we're only beginning to understand, generating killer waves through processes that blend predictable physics with chaotic emergent behavior. These waves represent the visible manifestation of complex mathematics expressing itself through water, equations made flesh in forms that can destroy the largest human constructions in seconds. Let's turn now to one of the ocean's most persistent auditory mysteries: underwater explosions and booming sounds that occur with no visible source or explanation. Submarine crews and oceanographic research vessels occasionally detect powerful explosive sounds from deep water that register on multiple hydrophones, yet correlate with no known human activity or geological event. These sounds often feature acoustic signatures resembling detonations, with sharp pressure rises followed by characteristic pressure decay patterns consistent with explosion physics. Yet investigation reveals no debris, no military exercises, no seismic activity, nothing that explains auditory events powerful enough to be detected hundreds of miles away. What natural or artificial processes could generate explosion-like acoustic signatures in deep ocean environments while leaving no other evidence of their occurrence? Some researchers suggest these sounds might result from spontaneous methane bubble releases from seafloor deposits, creating powerful acoustic events as large gas volumes rapidly expand during ascent. Others propose underwater landslides or sudden collapse of submarine geological features might generate the acoustic signature of explosions without surface manifestation. More exotic explanations include cavitation events, the formation and immediate collapse of vacuum bubbles in water due to pressure differentials, occurring on scales large enough to generate explosion-like acoustics. Could the immense pressure differentials in deep ocean environments create natural hydrodynamic phenomena that mimic artificial explosions through purely physical processes? The ocean's acoustic environment remains among its least understood aspects, with sound propagation affected by temperature layers, salinity gradients, and pressure variations that create complex transmission paths for mysterious signals. Now let's examine one of the ocean's most visually confounding mysteries: underwater clouds and rivers of apparent smoke that flow along the seafloor or hang suspended in mid-water. These ghostly formations, documented by submersibles and divers worldwide, resemble atmospheric clouds or smoke plumes, yet exist in environments where combustion is impossible. Some form distinct layers that maintain their structure for hours or days, while others flow like rivers along the contours of the seafloor, following underwater terrain with fluid-like properties. The most dramatic examples create the visual impression of underwater weather systems, complete with thunderhead formations and flowing storm fronts that progress through the water column. What creates these cloud-like structures in environments where conventional cloud formation processes cannot possibly operate? Scientific investigation has identified several mechanisms behind these formations, including haloclines, boundaries between water masses of different salinity, thermoclines, temperature boundary layers, and suspended sediment flows. Particularly dramatic examples often involve hydrogen sulfide emissions from hydrothermal vents, which create billowing white smoke as the compound oxidizes in seawater. Yet some underwater cloud formations demonstrate behaviors that resist these explanations, including apparent responses to external stimuli and organization patterns, suggesting emergent complexity. Could certain underwater cloud formations represent colonial organisms operating at scales that obscure their biological nature to human observers? Might some represent chemical reaction systems that achieve self-organization through processes similar to those that may have led to the origin of life itself? The visual similarity between underwater clouds and atmospheric weather systems raises an intriguing possibility. Perhaps the principles governing fluid dynamics create parallel phenomena across different mediums, generating similar structural patterns, whether in air or water. These underwater formations may represent the ocean's version of weather systems, operating according to similar physical principles but expressed through different materials and at different scales. What might we learn about atmospheric processes by studying their underwater counterparts, where observation is possible without the interference of participating in the system being studied? The ocean provides a parallel laboratory for fluid dynamics, potentially offering insights into atmospheric behaviors through analogous underwater phenomena that operate at more accessible scales and timeframes. These underwater clouds represent visible manifestations of fluid dynamics principles that transcend the specific medium, revealing underlying mathematical patterns that govern flow systems throughout our planet. Let's explore a truly bizarre oceanic phenomenon: underwater crop circles and geometric patterns that appear on the seafloor with no clear formation mechanism. Beyond the pufferfish-created patterns mentioned earlier, divers and research vessels have documented perfect circles, spirals, and complex geometric formations on the seafloor in locations ranging from the Baltic Sea to the coast of Western Australia. These patterns sometimes span hundreds of feet in diameter and feature precision that seems inconsistent with random natural processes or known marine animal behavior. Some appear overnight in areas previously documented as featureless sand, while others seem to remain stable for years, despite strong currents that should erase any surface markings. What processes, biological, geological, or otherwise, could create and maintain such precise geometric patterns in underwater environments? While some formations have been attributed to specific causes, like sand dollar colonies creating small-scale patterns through collective movement, many larger-scale geometric seafloor features remain unexplained. Proposed mechanisms include interactions between ocean currents and seafloor topography, creating standing wave patterns that sort sediment into geometric arrangements. Others suggest bacterial or microbial colonies might generate large-scale patterns through collective growth behaviors, similar to the way slime molds can create complex optimization networks. More controversial explanations propose these patterns might represent evidence of intelligent intervention, whether from human technology or more exotic sources. The seafloor's vastness and our limited observation capabilities mean countless such formations likely exist undocumented, with their origins and purposes remaining complete mysteries. Perhaps the most famous underwater geometric anomaly is the Baltic Sea object, discovered in 2011 by the Swedish diving team Oceanic. Sonar images revealed a remarkably circular formation, approximately 200 feet in diameter, resting at 300 feet depth, with apparent structural features resembling ramps, stairs, and right-angled elements. More intriguing were reports that electronic equipment malfunctioned when in close proximity to the formation, with cameras and satellite phones allegedly failing until the divers moved away from the object. While skeptics reasonably suggest the formation represents a natural geological structure, possibly a glacial deposit or volcanic feature, its geometric regularity and reported electronic effects continue to resist conventional explanation. The Baltic Sea object remains incompletely documented, with limited funding for proper scientific investigation, leaving its nature and origin in the realm of speculation. Let's turn our attention to one of the most mathematically perplexing ocean mysteries, the phenomenon of crossing seas, where wave systems from different storms intersect to create geometric patterns on the ocean surface. These intersections sometimes generate perfect squares or hexagons of water, creating the surreal visual impression of a chessboard stretching to the horizon. Satellite imagery has captured these formations, spanning hundreds of square miles, with wave peaks and troughs, arranging themselves into geometric grids of remarkable precision. While the basic mechanism intersecting wave trains from different directions is understood, the mathematical perfection these systems sometimes achieve raises deeper questions about emergent order in complex systems. What principles govern the transformation from chaotic wave interaction to geometric perfection under specific conditions? Particularly interesting is the connection between crossing seas and rogue wave formation, as these geometric patterns occasionally spawn individual waves of extraordinary height. The mathematical principles involved, constructive and destructive interference, nonlinear wave dynamics, and phase synchronization, represent some of the most complex areas of hydrodynamics. Could understanding these spontaneous geometric formations provide insights into quantum wave function behavior, as some physicists have suggested? Might the ocean be demonstrating macroscopic versions of quantum principles, visible to the naked eye yet operating according to mathematics, usually reserved for subatomic particles? These geometric wave patterns represent natural mathematics expressing itself through water, creating visible manifestations of equations that typically remain hidden in abstract realms. Now let's dive into one of the ocean's most persistent legends, mermaids, or humanoid creatures allegedly observed in marine environments worldwide for centuries. While conventional science dismisses such accounts as misidentification of known marine mammals, particularly dugongs and manatees, or pure fiction, the specificity and consistency of some reports from credible observers raises questions about whether something unusual might occasionally be glimpsed in our oceans. In 2012, Animal Planet aired a controversial documentary titled Mermaids: The Body Found, which presented a fictional narrative around the aquatic ape hypothesis, the speculation that some hominids might have evolved along a semi-aquatic evolutionary path. Though presented as entertainment, the program generated significant public interest and confusion about whether genuine evidence for humanoid marine creatures might exist. What element of human experience or psychology makes the mermaid archetype so persistent across virtually all maritime cultures, often with remarkably similar descriptions despite geographical isolation? While literal mermaids, as depicted in folklore, almost certainly don't exist, some biologists have suggested the possibility of convergent evolution creating superficially humanoid characteristics in marine mammals under specific evolutionary pressures. Others propose that ancient encounters with now extinct marine species, perhaps including unusual pinnipeds, the family, including seals and sea lions, might have seeded the original mermaid legends. Archaeological findings of modified human remains from coastal communities, including skeletal modifications to more closely resemble fish, suggest ritual practices that might have created the appearance of human-fish hybrids when glimpsed by foreign sailors. Could living humans modified for ceremonial purposes have been observed by distant seafarers, creating accounts that evolved into mermaid legends over centuries of retelling? The ocean's vastness and our limited exploration capabilities leave room for undiscovered marine mammals, with characteristics that might, under specific viewing conditions, create impressions resonating with the mermaid archetype. Let's consider a truly haunting oceanic phenomenon: the existence of immortal plastic waste accumulating in our oceans, creating artificial ecosystems with potentially far-reaching consequences for marine life. The Great Pacific Garbage Patch, a concentration of plastic debris in the North Pacific Gyre, spans an estimated 1.6 million square kilometers, approximately 3 times the size of France. Within this artificial ecosystem, plastic items from decades past float alongside newer debris, creating surreal juxtapositions of human consumption history, suspended in ocean currents. Particularly unsettling are discoveries of decades-old plastic items in perfect condition, their synthetic materials resistant to the decomposition processes that return natural materials to the environment. What long-term consequences might emerge from these immortal materials, accumulating in marine environments, over timescales measuring centuries or millennia? Recent research has documented the evolution of specialized microbial communities that colonize these floating plastic islands, creating what scientists now term the plastosphere, an entirely new ecological niche created by human waste. Some microorganisms appear to have developed capabilities to partially metabolize certain plastic compounds, suggesting evolutionary adaptation to these novel materials within remarkably short time frames. Could these plastic-adapted microbes eventually evolve capabilities to break down synthetic materials that currently persist for centuries? Might they develop metabolic pathways that generate unexpected byproducts, potentially including compounds toxic to traditional marine life? These artificial ecosystems represent unintentional evolutionary experiments playing out in real time across our oceans, with unknown consequences for marine biology and potentially human health. Perhaps most disturbing is evidence that plastic particles now pervade every level of the marine food web, from microscopic plankton to apex predators. These microplastics have been documented in the deepest ocean trenches in the most remote Arctic ice, demonstrating distribution patterns that leave no marine environment untouched. Studies increasingly suggest these particles can cross cellular boundaries and accumulate in animal tissues, potentially including those consumed by humans. What biological effects might emerge from this unprecedented introduction of synthetic materials into living systems evolved over millions of years without exposure to such compounds? The ocean is now conducting an uncontrolled experiment in evolutionary adaptation to artificial materials, with billions of organisms serving as unwitting test subjects for humanity's disposable convenience items. Let's explore the mysterious 52 Hz whale, sometimes called the loneliest whale in the world, a creature that calls at a frequency no other known whale uses. First detected in 1989 by U.S. Navy hydrophones, designed to track Soviet submarines, this unique individual produces calls at approximately 52 Hz, significantly higher than the 15-25 Hz typical of blue whales or the 10-39 Hz used by fin whales. For over 3 decades, This solitary voice has been tracked migrating along routes similar to blue whales but never apparently receiving a response to its distinctive calls. The whale's migration patterns don't match any known species precisely, suggesting it may be a hybrid between different whale species or perhaps the last member of an unclassified species. What does it mean for a social, communicative creature to spend decades calling out without response, a voice singing alone in the vastness of the ocean? Particularly poignant is the apparent evolution of the 52 Hz whale's call over decades of monitoring, with subtle shifts in pattern and sometimes frequency suggesting potential attempts to modify its communication. Some researchers speculate these changes might represent efforts to generate responses from other whales after years of silence. Others suggest the frequency shifts might result from aging, injury, or anatomical abnormalities that prevent normal vocalization. Could this unique individual represent a new evolutionary direction for cetaceans, perhaps the first member of an emerging species with different communication patterns? Might it be calling to others like itself that exists beyond our current monitoring capabilities, participating in a conversation we can detect only partially? The public fascination with the 52 Hz whale reveals something profound about human psychology, our tendency to project our own fears of isolation onto other beings, particularly those whose experiences seem to mirror our own emotional landscapes. The whale has become a cultural touchstone, inspiring music, art, literature, and documentary films, exploring themes of loneliness and connection. What does it tell us about ourselves that this solitary marine voice has resonated so deeply with human audiences worldwide? Perhaps the 52 Hz whale serves as a powerful metaphor for the modern condition, calling out in ways others cannot comprehend, moving through the world alone despite being surrounded by potential connections. The ocean sometimes presents us with mysteries that function as mirrors, reflecting our own deepest fears and longings back to us through the experiences of its inhabitants. Let's examine the perplexing case of the Mary River turtle, an Australian freshwater species with the extraordinary ability to breathe through its genitals, allowing it to remain underwater for up to 3 days continuously. While not strictly an ocean mystery, this remarkable adaptation demonstrates the extremes of evolutionary possibility in aquatic environments. The turtle's specialized cloaca contains gill-like structures that extract oxygen from water, supplementing the oxygen obtained through more conventional lungs when it surfaces. Even more bizarrely, this unusual respiratory adaptation sometimes results in the growth of green algae on these specialized tissues, creating individuals that appear to have living green mohawks. What evolutionary pressures could possibly select for such an extraordinary and seemingly improbable biological adaptation? Scientists suggest this unusual breathing mechanism evolved in response to the specific environmental conditions of the Mary River, which features both fast-flowing sections requiring underwater stability and predator-rich environments where surfacing creates vulnerability. The ability to remain submerged for days provides significant survival advantages in such conditions, even if the resulting mechanism seems bizarrely inefficient from an engineering perspective. Could similar evolutionary pressures in deep ocean environments have produced equally unusual respiratory adaptations in species we haven't yet discovered? Might the crushing pressures and oxygen-poor conditions of the deep sea have selected for biological innovations that would seem equally improbable if we encountered them? The ocean's evolutionary laboratory operates across vast timescales and extreme environments, potentially producing adaptations that challenge our understanding of biological possibility. Now let's consider one of the ocean's most mystifying mathematical patterns, the spiral swimming behavior observed in certain shark species when in the presence of electromagnetic fields. When exposed to even weak electrical currents in seawater, some sharks enter spiraling swimming patterns of remarkable mathematical precision, tracing logarithmic spirals identical to those found in nautilus shells, hurricane formations, and spiral galaxies. These patterns emerge spontaneously, without apparent conscious direction from the animal, suggesting fundamental connection between electromagnetic sensitivity and mathematical principles expressed through movement. The behavior likely evolved to help sharks locate prey using electromagnetic sensing of muscle activity, but the mathematical precision of the resulting movement patterns raises deeper questions. How does a shark's neurological system encode the complex mathematics of logarithmic spirals without any apparent computational capacity for such calculations? Some biophysicists suggest these spiral patterns represent emergent properties of simple sensory rules, where straightforward neurological responses to electromagnetic gradients naturally generate complex mathematical patterns. Others propose more fundamental connections between electromagnetic fields and spatial organization, suggesting these patterns reflect underlying physical principles that transcend the specific organism. Could sharks be demonstrating a form of embodied mathematics, where complex patterns emerge, not through calculation, but through direct physical response to environmental stimuli? Might similar principles operate in human intuition, where we sometimes arrive at mathematically optimal solutions without conscious calculation? The ocean occasionally offers glimpses of living mathematics, where abstract principles find expression through biological systems responding to physical forces in ways that generate unexpected complexity and beauty. Let's explore one of the most unsettling acoustic mysteries of the deep, the sound known as the whistle, recorded by deep-sea hydrophones in the Pacific Ocean in 1997. Unlike other unexplained ocean sounds that feature relatively consistent acoustic profiles, the whistle begins as a low moan before rapidly ascending to a high-pitched whistle that exceeds the typical vocal range of any known marine mammal. The sound's modulation pattern suggests intelligent control rather than random geological processes, with frequency changes that appear almost musical in structure. Yet no known creature in Earth's oceans should be capable of producing this particular acoustic signature, especially at the volume detected by multiple hydrophones thousands of miles apart. What biological or geological process could generate such a precisely modulated sound at sufficient volume to travel across ocean basins? Some researchers suggest the whistle might represent a previously undocumented vocalization from a known whale species, perhaps produced under unusual physical or social circumstances. Others propose it might come from deep ocean currents interacting with peculiar seafloor formations, creating resonant cavities that amplify and modulate sound in unexpected ways. More exotic explanations include the possibility of hybrid communication between different cetacean species, attempting to establish cross-species dialogue. Could intelligent marine species occasionally attempt communication across biological boundaries, generating vocalizations outside their typical patterns in efforts to bridge evolutionary divides? The ocean's acoustic environment remains one of its least understood aspects, with sound propagation affected by temperature layers, pressure gradients, and underwater topography that create mysterious transmission paths for unexplained signals. Now let's examine the mysterious case of the black smokers, hydrothermal vents that expel mineral-rich water at temperatures exceeding 700 degrees Fahrenheit, supporting ecosystems entirely independent from sunlight energy. These submarine volcanic features weren't discovered until 1977, highlighting how recently humanity has begun to understand even basic features of deep ocean environments. The ecosystems surrounding these vents operate on chemosynthesis rather than photosynthesis, deriving energy from the oxidation of hydrogen sulfide and other compounds, rather than sunlight. Perhaps most remarkably, genetic analysis suggests organisms in these communities may represent some of Earth's earliest life forms, potentially preserving biological patterns dating back billions of years. What might these ancient ecosystems tell us about the origin of life on Earth and potentially other worlds? Particularly intriguing is the rapid colonization observed when new hydrothermal vents form after underwater volcanic activity. Within months, complex ecosystems featuring specialized organisms appear around newly formed vents, despite their isolation from similar habitats by many miles of inhospitable ocean floor. How do these highly adapted organisms locate new vents across such vast distances in the darkness of the deep ocean? Some researchers suggest chemical sensing capabilities far beyond our current understanding, while others propose these organisms might detect subtle electromagnetic signatures associated with hydrothermal activity. These vent communities demonstrate life's remarkable ability to exploit energy sources wherever they exist, raising the possibility that similar chemosynthetic ecosystems might thrive on ocean-bearing worlds throughout our solar system and beyond. Let's turn our attention to the puzzling phenomenon of undersea nuclear weapons tests and their long-term effects on deep ocean environments. Between 1946 and 1996, various nations conducted approximately 50 nuclear detonations in marine environments, releasing radioactive materials and generating pressure waves that propagated throughout the global ocean. Despite the extreme destructive force of these explosions, some exceeding 50 megatons, their long-term environmental impacts remain incompletely understood due to the difficulties of monitoring deep ocean environments. Particularly concerning are indications that certain radioactive isotopes have concentrated in deep-sea trenches, potentially creating localized radiation hotspots in some of Earth's most inaccessible environments. What unforeseen consequences might emerge from these artificial introductions of radioactive materials into deep marine ecosystems operating on evolutionary timescales, measuring billions of years? Some research suggests certain deep-sea organisms may have developed unexpected responses to radiation exposure, potentially including enhanced growth rates in some bacterial species, exposed to elevated radiation levels. Could these exposures be driving accelerated evolution in certain marine microorganisms, potentially creating novel biological capabilities through radiation-induced genetic modifications? Might some deep-sea creatures have developed mechanisms to utilize radioactive materials in their metabolic processes, similar to the way certain bacteria can metabolize toxic heavy metals? The ocean's evolutionary laboratory responds to all available energy sources and materials, potentially including those introduced through human military activities. These underwater nuclear tests represent unintentional experiments in radiation biology, playing out across decades in environments we can barely access, with consequences that may not become apparent for centuries. Let's explore one of the ocean's most enigmatic meteorological phenomena, rogue holes in clouds that appear directly above certain ocean regions, creating perfect circles of clear skies surrounded by cloud cover. These formations, sometimes called punch-hole clouds or fall streak holes, can span several miles in diameter and often persist for hours before the surrounding clouds close the gap. While meteorologists attribute most such formations to aircraft passing through supercooled cloud layers, causing water droplets to freeze and fall as snow or rain, some oceanic examples occur in regions with minimal air traffic. Particularly intriguing are reports of circular cloud holes forming directly above certain underwater features, including seamounts and hydrothermal vent fields. Could thermal energy or other emissions from these seafloor features sometimes influence cloud formation in the atmosphere miles above? Some researchers suggest these correlations between seafloor features and atmospheric phenomena might result from complex interactions between ocean currents, surface temperature patterns, and air circulation. Others propose more direct connections, including the possibility that electromagnetic emissions from certain geological formations might influence cloud condensation nuclei through ionization effects. More exotic explanations include the possibility that energy exchanges between oceanic and atmospheric systems might occasionally create self-organizing patterns across different physical mediums. Could the ocean sometimes communicate with the atmosphere through physical processes we haven't yet identified, creating visible signatures of subsurface features in the clouds above? These atmospheric windows potentially represent visible manifestations of energy transfer between ocean and atmosphere, revealing connections between different Earth systems that typically remain invisible to surface observers. Now let's examine the mysterious phenomenon of Milky Seas, vast regions of ocean surface that glow with an eerie blue-white bioluminescence, visible from orbit. Unlike typical marine bioluminescence, which manifests as brief flashes when water is disturbed, Milky Seas create continuous illumination across thousands of square miles, transforming night into ghostly twilight for sailors who encounter them. The phenomenon has been reported in maritime records for centuries, with the earliest scientific description appearing in Jules Verne's 20,000 Leagues Under the Sea, based on actual sailor accounts. Modern satellite confirmation began in 2005, when instruments captured an event in the Indian Ocean that illuminated approximately 6,200 square miles for 3 consecutive nights. What biological mechanisms could generate bioluminescence on such massive scales, maintaining continuous light production rather than the brief flashes, typical of most light-producing marine organisms? The current scientific explanation attributes Milky Seas to luminous bacteria, Vibrio harvey, colonizing microalgae blooms, creating a biological light system operating on industrial scales. Yet questions persist about triggering mechanisms that cause these bacteria to illuminate simultaneously across thousands of square miles, maintaining synchronization for multiple nights. Some researchers suggest atmospheric electrical phenomena might provide the triggering mechanism, perhaps through subtle changes in water surface charge during certain weather conditions. Others propose that pressure waves from seismic events might synchronize bacterial light production through mechanical stimulation. These explanations remain speculative, as scientists have directly sampled active Milky Seas only once, during a 1985 research vessel encounter in the Arabian Sea. Perhaps most intriguing about Milky Seas are observer reports describing the illumination appearing to respond to vessel movement, sometimes seeming to track ships through the glowing waters. While likely representing the interaction between vessel wakes and bioluminescent organisms, these descriptions from experienced mariners suggest behavior patterns more complex than simple mechanical stimulation. Could bacterial colonies develop emergent properties that mimic intentional response when operating at massive scales? Might oceanic bioluminescence represent a form of communication between microorganisms operating on spatial and temporal scales we struggle to recognize as meaningful? The ocean's most spectacular light shows may represent biological communication systems whose patterns and purposes remain entirely opaque to human understanding. Let's examine the unsettling case of the Baltic Sea UFO, an approximately 200-foot diameter circular formation discovered at 300 feet depth by the Swedish diving team Oceanic in 2011. Sonar images revealed a remarkably symmetrical object with apparent structural features, including straight edges, right angles, and what appeared to be an entrance ramp extending approximately 500 feet across the seafloor. Most intriguing were reports that electronic equipment malfunctioned when in close proximity to the formation, with cameras and satellite phones allegedly failing until the divers moved away from the object. While professional geologists suggest the formation likely represents a natural glacial deposit, potentially a circular moraine or volcanic feature, its geometric regularity and reported electronic effects continue to generate speculation. What natural geological processes could create such precise geometric features on the seafloor, and what physical properties might cause localized electronic disruption? Some researchers propose the formation might represent a Nazi-era experimental weapon or submarine technology lost during World War II, noting the Baltic's history as a testing ground for advanced German military projects. Others suggest it could be a modern military installation, potentially a sonar array or other surveillance technology deliberately placed to monitor submarine traffic in the strategically important Baltic Sea. More exotic explanations include the possibility of a crashed extraterrestrial craft or ancient technological artifact from a prehistoric advanced civilization. While such speculative theories lack supporting evidence, the incomplete documentation of the formation, resulting from limited funding for proper scientific investigation, leaves room for continued mystery. The Baltic Sea object demonstrates how challenging it remains to properly investigate underwater anomalies, even in relatively accessible locations, due to the significant resources required for deep-sea research. Let's turn our attention to one of the most unsettling inhabitants of the deep pool, the bobbit worm Unease aphroditos, a predatory polycete that can reach lengths exceeding 10 feet while remaining almost completely hidden beneath the ocean floor. These ambush predators bury their segmented bodies in seafloor sediment, extending only sensory antennae to detect passing prey before erupting from the substrate with jaw-like structures capable of slicing fish in half. Their hunting strategy involves incredible patience, sometimes remaining motionless for hours or days, while waiting for suitable prey to pass within striking distance. Most disturbing is their demonstrated ability to capture and consume prey substantially larger than themselves, dragging struggling victims into the seafloor through sheer muscular strength. What evolutionary pressures could produce such a specialized and terrifying hunting strategy, and what might it tell us about the competitive dynamics of deep ocean ecosystems? Particularly unsettling is the bobbit worm's extreme sensory sensitivity, which allows it to distinguish between the water displacement patterns of potential prey and non-prey organisms passing overhead. This sophisticated detection system enables remarkably accurate target selection, despite the worm having no conventional eyes or visual processing capabilities. Some marine biologists suggest this sensory system represents an entirely different evolutionary approach to predation, one based on vibration patterns and water pressure differentials, rather than visual or chemical cues. Could similar sensory adaptations exist in even larger predatory organisms, lurking within deep ocean sediments, perhaps explaining some unexplained disappearances of marine equipment and occasionally divers? The ocean floor potentially harbors numerous ambush predators, operating according to hunting strategies fundamentally different from those we've documented, hidden beneath a seemingly innocuous surface that conceals remarkable evolutionary innovations. Now let's explore one of the ocean's most beautiful but deadly mysteries, oceanic bioluminescence, that appears to respond intelligently to human presence. In certain tropical waters, particularly in parts of Southeast Asia, swimmers occasionally encounter bioluminescent organisms that create light patterns mimicking human body outlines with uncanny precision. Unlike conventional marine bioluminescence, which typically illuminates in response to any physical disturbance, these specialized organisms appear to selectively illuminate human forms while ignoring other moving objects of similar size. The effect creates the eerie impression of a luminous doppelganger swimming beneath the actual person, mirroring their movements with precision that suggests recognition rather than simple reaction. What biological mechanisms could possibly enable microscopic organisms to distinguish human forms from other similarly sized objects moving through the water? Some marine biologists propose these effects result from complex interaction between human body oils, electrical fields generated by muscle activity, and specialized chemical receptors in certain dinoflagellate species. Others suggest the apparent intelligent response represents an optical illusion created by the human visual system's tendency to recognize patterns, particularly those resembling human forms. More intriguing possibilities include the existence of colonial organisms that have evolved specialized responses to large predators, potentially including humans who have harvested these waters for millennia. Could long-term evolutionary exposure to human fishing activities have selected for organisms that recognize and respond to human presence as a survival adaptation? The ocean occasionally presents phenomena that appear to demonstrate intelligence or recognition, but likely operate through entirely different biological mechanisms that create the appearance of cognition without the associated neural structures. Let's turn our attention to one of the most disturbing deep-sea adaptations, parasitic behavior, so extreme it transforms the host into a functionally different organism. The tongue-eating louse, Cymathoa exigua, represents perhaps the most dramatic example, entering a fish's mouth through the gills before attaching to the tongue. The parasite then consumes the tongue's blood supply, causing it to atrophy and eventually detach, at which point the parasite attaches itself to the tongue stump and functionally replaces the organ. Most disturbing is the parasite's ability to operate the host's former tongue muscles, allowing it to move and function as the fish's new tongue for the remainder of the host's life. What evolutionary pathway could possibly lead to such precise organ replacement, and what might it suggest about other potential parasitic relationships in deep ocean environments? While the tongue-eating louse represents an extreme example, marine biologists have documented numerous other parasites that manipulate host behavior or physiology in sophisticated ways. Some parasitic barnacles hijack crab nervous systems, causing male hosts to develop female characteristics and care for barnacle eggs, as if they were their own offspring. Others induce fish to swim erratically near the surface, increasing visibility to predatory birds that serve as the parasite's next host. Could undiscovered deep-sea parasites exist with even more sophisticated host manipulation capabilities, potentially altering complex behaviors or cognitive functions in larger marine organisms? The ocean's parasitic arms race has continued for hundreds of millions of years, potentially producing manipulation strategies so sophisticated they become indistinguishable from the host's natural behaviors. Now let's examine a truly bizarre oceanic habitat, the ecosystem that develops inside and around whale falls, the carcasses of dead whales that sink to the deep ocean floor. When a whale dies and sinks into the abyss, its massive body, sometimes exceeding 200 tons, creates a localized ecosystem that can support specialized organisms for up to 100 years from a single carcass. The decomposition occurs in distinct phases, beginning with mobile scavengers that consume soft tissues, followed by enrichment opportunists that colonize bones and surrounding sediments, and finally, sulfophilic organisms that derive energy from chemicals released during decomposition. Most remarkable are the specialized organisms found nowhere else on Earth, except on whale falls, having evolved specifically to exploit this transient but nutrient-rich habitat. What evolutionary pathways could produce organisms so specialized they can exist only on the decomposing remains of the ocean's largest inhabitants? Particularly fascinating are bone-eating zombie worms, Ulzidax species, that use root-like structures to penetrate whale bones and extract collagen and lipids, using specialized symbiotic bacteria. These organisms lack mouths or digestive systems entirely, having evolved complete dependence on their bacterial partners to convert whalebone compounds into usable nutrition. Even more remarkably, genetic evidence suggests these specialized decomposers evolved relatively recently, potentially within the past 100 million years, as whales themselves evolved. Could similar specialized decomposer communities exist for other large marine organisms we haven't yet documented, perhaps including species known only from fossil evidence? The ocean's decomposition cycles represent critical but largely invisible components of marine ecosystems, with specialized organisms ensuring that even the largest creatures eventually return their components to the biological cycle. Let's now consider one of the ocean's most visually striking mysteries: underwater rivers and lakes with distinct shorelines, surfaces, and even waves that exist entirely beneath the ocean itself. These submarine hydrological features form when water of different density, usually due to higher salinity or temperature differences, flows along the seafloor or creates stable layers within the water column. The most dramatic examples create the visual impression of terrestrial landscapes underwater, complete with rippled surfaces, coastal vegetation in the form of specialized organisms, and distinct boundaries between air, normal seawater, and water, denser brine. Divers who visit these formations report the uncanny experience of seeming to fly above underwater shorelines, watching particulate matter flow along riverbanks that exist in a wholly aquatic world. What other terrestrial-like features might exist in deep ocean environments, creating parallel versions of familiar landscapes in the alien context of the deep sea? Particularly striking are underwater waterfalls, where denser water cascades over submarine cliffs in visible curtains flowing through the surrounding ocean. These hydrodynamic features can span hundreds of feet in height, creating spectacular visual phenomena for the few human observers fortunate enough to witness them directly. Some submarine rivers carry significant suspended sediment loads, particulate matter flowing within the denser water layer, creating underwater analogs to terrestrial muddy rivers after rainfall. Could these underwater hydrological systems play previously unrecognized roles in ocean chemistry and nutrient cycling, transporting materials through the water column in patterns we've only begun to document? The ocean contains parallel versions of virtually every terrestrial landscape feature, expressed through density differences rather than the air-water boundary that defines similar features on land. Let's examine one of the ocean's most perplexing geological features, massive underwater sinkholes known as blue holes, which plunge hundreds of feet downward from relatively shallow coastal waters. These vertical caves form when rainwater erodes limestone over millennia, creating enormous cylindrical shafts that later become submerged due to rising sea levels. The most famous example, the Great Blue Hole off Belize, measures approximately 1,000 feet across and descends 400 feet into darkness, with perfectly vertical walls creating the visual impression of a gigantic drain in the ocean floor. What makes these formations particularly mysterious is their often completely isolated nature. Many blue holes show no apparent connection to surrounding water circulation patterns, creating stagnant, often oxygen-depleted environments with unique chemical properties. What biological adaptations allow organisms to survive in these isolated underwater caves with their extreme chemical conditions and minimal energy inputs? Exploration of blue holes has revealed surprising archaeological findings, including perfectly preserved human remains dating back thousands of years. The oxygen-poor environment within some blue holes prevents normal decomposition processes, creating natural preservation conditions for organic materials that would quickly deteriorate in typical marine environments. Some blue holes contain distinct water layers with dramatically different chemical properties, including anoxic zones where hydrogen sulfide creates water that would be immediately toxic to most marine organisms. Could these isolated underwater environments preserve evidence of historical events or extinct species that would have decomposed in normal ocean conditions? Blue holes represent natural time capsules within the ocean, preserving materials and potentially organisms in conditions that have remained stable for thousands of years, while the surrounding marine environment has undergone significant changes. Now let's turn our attention to one of the most unsettling acoustic phenomena in the deep infrasound waves that propagate through ocean waters at frequencies below human hearing, but potentially affecting marine life in profound ways. These extremely low-frequency pressure waves can travel thousands of miles through seawater, potentially carrying information across entire ocean basins. While humans cannot hear these sounds, many marine mammals appear highly sensitive to them, with evidence suggesting whales can detect and potentially communicate using infrasound over distances exceeding 1,000 miles. Perhaps most disturbing is the growing evidence that human-generated infrasound, from shipping, military sonar, and industrial activities, may disrupt natural communication patterns that have evolved over millions of years. What crucial information might be carried in these inaudible frequencies, and how might their disruption affect species that depend on them for navigation, mating, or social cohesion? Particularly concerning is the correlation between certain naval sonar exercises utilizing powerful low-frequency systems and mass stranding events involving deep-diving whale species. These strandings often involve multiple individuals simultaneously beaching themselves, sometimes with evidence of internal injuries consistent with rapid ascent from deep water, as if the animals fled upward in panic from something in the depths. Post-mortem examinations have revealed bleeding around the brain and ears in some stranded individuals, suggesting acoustic trauma potentially linked to powerful human-generated sound sources. Could our technological activities be inadvertently creating an acoustic environment that appears threatening or disorienting to species whose sensory systems evolved in a significantly quieter ocean? The water carries our technological footprint in ways we cannot directly perceive, but that may fundamentally alter the sensory landscape for creatures who evolved in acoustic environments, predating human industrial activity by millions of years. Let's explore one of the most mathematically beautiful ocean mysteries, the spiral shell of the chambered nautilus, which grows according to a perfect logarithmic spiral mirroring patterns found throughout nature and the cosmos. This remarkable cephalopod constructs its shell by adding progressively larger chambers in a pattern, precisely following the golden ratio, approximately 1.618, creating a spiral that could theoretically continue expanding forever while maintaining its perfect proportional relationships. What makes this mathematical precision particularly mysterious is that the nautilus possesses a relatively simple nervous system, with no apparent capacity for the complex calculations necessary to create such a mathematically perfect structure. Yet generation after generation, for more than 500 million years, nautiluses have constructed shells following this precise mathematical pattern without variation. How does biological evolution encode such perfect mathematical relationships into genetic instructions without any apparent computational capacity to calculate or verify the resulting structures? Some biophysicists suggest these mathematical patterns emerge naturally from simple growth rules, interacting with physical constraints, where basic biological processes inevitably generate complex mathematical structures without requiring explicit calculation. Others propose more fundamental connections between mathematics and biological processes, suggesting certain mathematical relationships represent optimal solutions that evolution naturally discovers through trial and error across millennia. Could the nautilus shell represent a physical manifestation of mathematical principles that exist independently of human formalization, natural laws expressing themselves through biological growth patterns? Might similar mathematical principles operate throughout nature, generating complex patterns that appear designed but emerge from fundamental properties of matter and energy interacting over time? The ocean occasionally offers glimpses of pure mathematics expressed through living organisms, suggesting deeper connections between abstract numerical relationships and the physical processes that shape life across evolutionary timescales. Now let's consider one of the most visually dramatic ocean mysteries, marine snow, the continuous shower of organic particles that falls from surface waters to the deep ocean floor. This ghostly precipitation consists of dead organisms, fecal matter, mucus, and other biological materials that aggregate into visible flakes as they sink through the water column. In certain ocean regions, marine snow falls so densely it creates the visual impression of a blizzard, with countless white particles slowly descending through the darkness. What makes this phenomenon particularly important is its role in carbon sequestration. Marine snow represents one of Earth's primary mechanisms for removing carbon dioxide from the atmosphere and storing it in deep ocean sediments. How might changes in ocean chemistry, temperature, or circulation patterns affect this crucial planetary process that helps regulate our global climate? Recent research suggests marine snow composition has changed significantly in some ocean regions, with microplastic particles now integrated into the falling material. These synthetic components may alter sinking rates, decomposition patterns, and the nutritional value of marine snow for deep-sea organisms that depend on this material as their primary food source. Other studies indicate ocean acidification may affect the structural integrity of certain marine snow components, potentially altering carbon transfer efficiency between surface waters and the deep ocean. Could disruptions to marine snow composition or behavior contribute to feedback loops affecting carbon cycling and climate stability at global scales? This ghostly precipitation represents one of the ocean's most visually poetic yet functionally critical processes, a continuous transfer of matter and energy from the sunlit surface to the eternal darkness of the abyss. Let's examine one of the most persistent navigation mysteries, the North Atlantic's magnetic anomaly region, where compass readings become unreliable and electronic equipment occasionally malfunctions. This area, roughly corresponding with parts of the Bermuda Triangle, features localized variations in Earth's magnetic field that can cause compass needles to deviate by up to 20 degrees from true magnetic north. While variation itself is expected across Earth's surface, the rate of change in this region exceeds normal parameters, creating navigation challenges that have persisted since the age of maritime exploration. Historical ship's logs dating back centuries document compass problems in this region, suggesting the anomaly represents a stable feature rather than a temporary fluctuation. What geological or geophysical features might create such persistent disruption to Earth's magnetic field in this specific ocean region? Some geophysicists propose these anomalies might result from unusual concentrations of magnetic minerals in the ocean floor, potentially related to ancient volcanic activity or meteorite impacts. Others suggest interactions between the Earth's magnetic field and ocean currents rich in dissolved minerals might generate localized electromagnetic effects through mechanisms similar to a liquid dynamo. More exotic explanations propose crystalline structures deep within the Earth's crust might occasionally interact with solar radiation to create temporary magnetic disturbances in certain ocean regions. Could these magnetic anomalies indicate deeper structural features within the Earth that remain undetected by current geological survey methods? The ocean sometimes reveals the presence of invisible forces through their effects on human technology, pointing toward geological or physical processes operating beyond our current understanding. Now let's turn our attention to one of the ocean's most extraordinary mathematical mysteries, the perfect hexagonal columns of the Giant's Causeway and similar formations worldwide. While most famous examples occur on shorelines where they're partially exposed at low tide, identical formations exist completely submerged in numerous underwater locations. These remarkably precise geometric columns form through volcanic processes where basalt lava cools under specific conditions, causing the rock to contract and crack into perfectly hexagonal pillars. What makes these formations mathematically fascinating is their demonstration of how simple physical processes can generate perfect geometric forms without any biological or intelligent intervention. How do the basic laws of thermodynamics and material science create such precise mathematical patterns spontaneously in cooling rock? The hexagonal pattern represents the most efficient configuration for minimizing energy during cooling contraction, essentially the same mathematical solution that honeybees discover when building their combs. This geometric efficiency emerges naturally from physical processes rather than conscious calculation, demonstrating how fundamental mathematical principles express themselves through matter under certain conditions. Similar geometric patterns appear throughout nature, at various scales, from microscopic crystal structures to massive geological formations spanning miles. Could studying these natural expressions of geometric principles provide insights into mathematical laws that transcend their specific physical manifestations? The ocean occasionally preserves perfect geometric forms that suggest deeper mathematical order underlying apparently chaotic natural processes, visible evidence of how physical laws generate mathematical precision through simple interactions over time. Let's explore one of the ocean's most unsettling evolutionary mysteries, the independent evolution of complex eyes in unrelated marine species, suggesting visual perception represents an almost inevitable biological development under certain conditions. While land-dwelling vertebrates share common eye structures inherited from shared ancestors, octopuses and squid evolved camera-like eyes, nearly identical to human eyes, despite our last common ancestor being a flatworm without any visual organs, approximately 750 million years ago. This remarkable example of convergent evolution, where unrelated organisms develop similar structures independently, suggests the physics of light and optics constrain biological solutions to visual perception towards specific designs. What does this convergence tell us about evolutionary processes and the relationship between physical laws and biological structures? Could similar constraints shape the evolution of sensory systems on other worlds, potentially resulting in alien life with perceptual organs remarkably similar to Earth species, despite completely independent evolutionary histories? Particularly fascinating is the octopus eye's superiority to vertebrate eyes in certain aspects. They lack the blind spot present in human eyes where optic nerves pass through the retina, representing a more optimal engineering solution. This suggests evolutionary processes can sometimes discover superior design solutions along independent pathways, depending on the specific developmental constraints of different biological lineages. Could Earth's oceans harbor other examples of convergent evolution we haven't yet recognized, perhaps sensory systems operating according to principles we haven't identified? Might some apparent similarities between unrelated marine species actually represent sophisticated adaptations to environmental factors we don't yet understand? The ocean's evolutionary laboratory has operated continuously for over 3 billion years, potentially discovering biological solutions to environmental challenges through pathways human engineering has yet to consider. Let's examine one of the most counterintuitive ocean mysteries, underwater lakes and rivers of ultrasaline water that exist entirely within the ocean itself. These extraordinary hydrological features form when water with extremely high salt content flows along the seafloor, creating distinct boundaries between the denser brine and surrounding seawater. These underwater lakes feature their own shorelines, surface waves, and even distinct flora and fauna adapted to their unique chemical compositions. Particularly striking is the clear visual boundary between normal seawater and these hypersaline lakes, creating the surreal impression of an air-water interface existing entirely underwater. What specialized adaptations allow certain organisms to transition between these dramatically different chemical environments that exist in direct contact within the same physical space. Some of these underwater lakes contain water so dense with dissolved minerals that submarines can actually float on their surfaces, unable to penetrate the extreme density gradient without special ballast adjustments. The chemical composition of these brine pools often includes toxic concentrations of hydrogen sulfide and methane, creating environments lethal to most marine organisms, yet hosting specialized extremophile communities. Organisms that accidentally stray into these underwater lakes typically die almost instantly from osmotic shock and chemical toxicity, creating eerie shorelines occasionally littered with preserved remains of marine creatures. Could these isolated chemical environments preserve evidence of historical events or extinct species that would have decomposed in normal ocean conditions? These lakes within oceans represent natural laboratories for extremophile evolution, potentially harboring organisms with biochemical adaptations relevant to astrobiology and the search for life in our solar system's ice-covered ocean worlds. Now let's dive into one of the deep ocean's most puzzling communities, whale fall ecosystems, where specialized organisms appear to arrive at newly sunken whale carcasses with impossible speed and specificity. When a whale dies and sinks to the abyssal plain, its massive body creates a concentrated nutrient source that can support specialized organisms for up to 100 years. What perplexes marine biologists is how quickly certain highly specialized organisms locate and colonize these whale falls, despite their rarity and the vast distances separating them across the ocean floor. Some species appear at new whale falls within days, despite being found nowhere else in the marine environment and having limited mobility. What sensory mechanisms allow these organisms to detect whale falls across potentially hundreds of miles of open ocean, and how do they navigate to these isolated nutrient islands with such precision? Some researchers suggest these organisms might detect chemical signatures of decomposing whale tissue carried by ocean currents, potentially sensing compounds at concentrations of parts per trillion. Others propose more exotic detection mechanisms, including sensitivity to minute pressure changes or vibrations generated by scavenger activity at whale fall sites. Particularly mysterious are bone-eating Abyssal worms, which appear at whale falls despite having no apparent means of long-distance locomotion in their adult form. Could these specialized decomposers maintain dormant populations widely distributed across the seafloor, activating only when specific chemical signatures indicate a nearby whale fall? Might certain whale fall specialists have evolved symbiotic relationships with mobile marine organisms that transport them to new sites, creating biological dispersal networks we haven't yet documented? The ocean's decomposition specialists demonstrate sensory and dispersal capabilities that challenge our understanding of information transfer in deep-sea environments, suggesting communication networks operating through chemical, pressure, or vibrational pathways we've barely begun to investigate. These capabilities likely evolved in response to the spatial distribution of large marine carcasses throughout evolutionary history, creating specialized detection systems aligned with specific nutrient sources. What other sensory modalities might have evolved in the deep ocean, attuned to environmental signals we haven't identified or perhaps cannot perceive with our existing technology? The deep sea likely harbors perceptual worlds operating according to principles fundamentally different from those governing surface environments, adapted to extreme pressure, perpetual darkness, and three-dimensional spatial distribution. Whale fall ecosystems offer glimpses into these alternative perceptual realities, where organisms navigate and communicate through sensory channels, evolved specifically for the unique challenges of abyssal existence. Let's explore one of the ocean's most persistent human mysteries, the disappearance of lighthouse keepers from the Flannan Isles. Lighthouse in December 1900. 3 experienced keepers vanished simultaneously from this remote Scottish lighthouse during a violent storm, leaving behind a meal set on the table, clocks wound, and all equipment in perfect working order. The men's waterproof gear remained hanging inside the lighthouse, suggesting they had ventured outside unprotected despite the dangerous weather conditions. Official investigation concluded a rogue wave likely swept the men away while they secured equipment, yet questions persist about why all 3 experienced keepers would simultaneously violate safety protocols by leaving the lighthouse unattended. What circumstances could possibly lead 3 professional lighthouse keepers to abandon their post together during dangerous conditions, leaving behind essential safety equipment? Similar disappearances have occurred at other remote lighthouses worldwide, suggesting patterns that transcend coincidence or conventional explanation. The Eilean Moor Lighthouse incident shares remarkable similarities with Flannan Isles, with multiple keepers vanishing without trace despite locked doors and no signs of struggle. These patterns have generated speculation about psychological effects potentially associated with prolonged isolation in lighthouse environments, including shared hallucinations or perceptual distortions. Could certain combinations of atmospheric conditions, isolation, and constant exposure to specific sound frequencies from waves and foghorns create altered mental states in lighthouse keepers? Might some lighthouses occupy locations with unique geological or electromagnetic properties that occasionally affect human cognition or behavior through mechanisms we don't fully understand? The liminal nature of lighthouses, structures existing at the boundary between land and sea, often positioned on unusual geological formations, places them at the intersection of multiple natural forces. Their typical construction on exposed headlands or isolated rocks subjects them to extreme weather conditions, potentially including atmospheric electricity phenomena during storms. Could these unique environmental conditions occasionally generate unusual physical or psychological effects on human occupants through mechanisms not accounted for in conventional explanations of lighthouse keeper disappearances? The ocean boundary represents one of Earth's most energetic environmental transitions, where multiple physical forces converge in patterns that may occasionally produce anomalous effects on human perception or behavior. Lighthouse keeper disappearances potentially represent the human dimension of ocean mystery, where a limited understanding of marine boundary phenomena occasionally intersects with human psychology in ways that leave persistent questions. Now let's examine one of the ocean's most unsettling acoustic phenomena, underwater explosions and implosions that occur without visible cause or explanation. Submarine crews and oceanographic research vessels occasionally detect powerful explosive sounds from deep water that register on multiple hydrophones, yet correlate with no known human activity or geological event. These sounds often feature acoustic signatures resembling detonations, with sharp pressure rises followed by characteristic pressure decay patterns consistent with explosion physics. Yet investigation reveals no debris, no military exercises, no seismic activity, nothing that explains auditory events powerful enough to be detected hundreds of miles away. What natural or artificial processes could generate explosion-like acoustic signatures in deep ocean environments while leaving no other evidence of their occurrence? Some researchers suggest these sounds might result from spontaneous methane bubble releases from seafloor deposits, creating powerful acoustic events as large gas volumes rapidly expand during ascent through the water column. Others propose underwater landslides or sudden collapse of submarine geological features might generate the acoustic signature of explosions without surface manifestation. More exotic explanations include cavitation events, the formation and immediate collapse of vacuum bubbles in water due to pressure differentials, occurring on scales large enough to generate explosion-like acoustics. Could the immense pressure differentials in deep ocean environments create natural hydrodynamic phenomena that mimic artificial explosions through purely physical processes? The ocean's acoustic environment remains among its least understood aspects, with sound propagation affected by temperature layers, salinity gradients, and pressure variations that create complex transmission paths for mysterious signals. Let's dive into one of the deep ocean's most beautiful mysteries: bioluminescent organisms that create patterns of light resembling constellations or galaxies in the absolute darkness. Beyond the familiar surface bioluminescence visible to night swimmers, the deep ocean hosts entire light-producing ecosystems, operating according to patterns and purposes we've only begun to understand. In certain deep-sea environments, bioluminescent organisms create stable light arrangements that remain consistent over time, with specific species maintaining position within these living light displays. Some of these illuminated communities appear to respond collectively to external stimuli, brightening, dimming, or changing color patterns in coordinated ways that suggest communication rather than random response. What information might be encoded in these bioluminescent displays, and what sensory systems have evolved to interpret these messages in the lightless depths? Particularly fascinating are living light chains, documented in certain deep-sea environments, where specialized organisms link physically to form string-like structures that emit coordinated light patterns. These formations sometimes span dozens of feet, creating what appear to be synchronized communication networks through the darkness. Some deep-sea bioluminescent displays show evidence of mathematical patterns in their organization, including Fibonacci-like spiral arrangements and hexagonal lattice structures. Could these geometric light arrangements serve functions beyond the commonly understood purposes of attraction, warning, or illumination? Might they represent complex communication systems, operating according to visual languages evolved specifically for the unique sensory environment of the deep ocean? The deep sea represents Earth's largest habitable environment, a three-dimensional realm of perpetual darkness, where light itself becomes a precisely controlled communication medium. The evolutionary pressure to develop and interpret light signals in this environment has potentially produced communication systems of remarkable sophistication, operating according to principles we've barely begun to decipher. What messages flow through these living light networks, carrying information through an environment where visibility extends only as far as self-generated illumination allows? The ocean's bioluminescent languages potentially represent communication systems as complex as human speech, but operating through entirely different sensory channels and evolve for environmental conditions fundamentally alien to our experience. These living light patterns may constitute evidence of sophisticated information exchange occurring continuously in the darkness beyond human perception, revealing cognitive networks operating according to principles we've yet to recognize as intelligence. Let's examine one of the most persistent maritime mysteries: the phenomenon of ghost ships, vessels found adrift with no crew yet in relatively good condition. Beyond the famous Mary Celeste case discussed earlier, numerous similar incidents have occurred throughout maritime history and continue into the present day. The Malaysian-flagged tanker GN Singh was discovered drifting off Australia's coast in 2006, with no crew, functioning engines, and food still in the galley refrigerators. In 2013, the yacht Kaz T was found perfectly intact off Australia's Great Barrier Reef, with its engine running, food on the table, and laptops still powered on, but its three-man crew had vanished without trace. What forces or circumstances could possibly cause experienced sailors to abandon functional vessels without apparent emergency, leaving personal belongings and essential safety equipment behind? Conventional explanations range from rogue waves causing panic to sudden gas emissions from cargo, creating toxic conditions that force rapid evacuation. Yet none fully account for the crew's failure to return to vessels once any immediate danger had passed, or the absence of distress calls in modern cases where radio equipment remained functional. More unusual theories suggest encounters with unusual natural phenomena, perhaps sudden, localized weather events, or rare oceanic conditions that leave no physical evidence once dissipated. Some researchers propose temporary oxygen depletion in certain marine areas might create conditions where crew members experience confusion or impaired judgment, leading to irrational abandonment decisions. Others suggest powerful infrasound generated by certain wave patterns might induce panic or disorientation through mechanisms similar to those documented in cases of haunted locations on land. Could previously undocumented atmospheric oceanic interaction effects occasionally create conditions that affect human cognition or decision-making in ways that leave no physical evidence? These ghost ship cases represent one of the ocean's most persistent patterns of mystery, where conventional explanations consistently fail to account for the specific details of vessel abandonment. Similar patterns have emerged with modern vessels, despite advanced safety equipment, communication technology, and training protocols designed specifically to prevent unexplained disappearances. The 2020 discovery of the fishing vessel Bella Amica drifting off Italy with a half-consumed meal still on the table, functional engine, and no signs of emergency mirrors 19th century cases with disturbing precision. This consistency across different eras, vessel types, and technological contexts suggests the underlying cause relates to fundamental oceanic phenomena rather than human error or specific vessel vulnerabilities. What aspect of the ocean environment might occasionally create conditions so immediately threatening that experienced maritime crews abandon otherwise safe vessels without accessing available safety equipment? The persistence of these cases across centuries suggests an ongoing interaction between oceanic conditions and human psychology that remains outside our current understanding of either field. Let's explore another persistent pattern in oceanic mystery: underwater lights that appear to move with purpose rather than drifting passively with currents. Submarine crews, deep-sea explorers, and offshore oil platform workers have reported observing unusual light sources at depths where sunlight cannot penetrate, and in patterns inconsistent with known bioluminescent organisms. Unlike the brief flashes or diffuse glows typical of marine bioluminescence, these observations often describe sustained, directional light sources that change course, sometimes appearing to react to human vessels or equipment. What makes these accounts particularly intriguing is their consistency across different observers, time periods, and ocean regions, suggesting phenomena beyond misidentification of known light sources. Could these observations represent unknown marine organisms with bioluminescent capabilities exceeding those we've documented, perhaps large colonial entities with coordinated light-producing cells? Some researchers propose these moving lights might represent previously undocumented geophysical phenomena, perhaps related to electrical discharges from certain seafloor mineral deposits or hydrothermal vents. Others suggest the possibility of undiscovered chemical reactions occurring in specific ocean regions that produce sustained light through mechanisms similar to chemiluminescence, but operating on larger scales. More exotic explanations include the possibility of advanced underwater technology operated by terrestrial organizations or even non-human intelligence, though such proposals remain firmly in the realm of speculation. What conventional science can confirm is that our documentation of deep-sea bioluminescent capabilities remains incomplete, with new light-producing organisms discovered regularly during deep ocean exploration. The ocean's darkness potentially harbors luminous phenomena operating according to biological or chemical principles, we've yet to identify, occasionally visible to human observers, but largely occurring beyond our limited presence in deep marine environments. Now let's examine one of the ocean's most perplexing meteorological mysteries: rogue waves that appear without warning even in relatively calm seas, defying conventional wave physics. Prior to the first instrumental recording of a rogue wave in 1995, maritime accounts of walls of water appearing suddenly from otherwise manageable seas were generally dismissed as sailor exaggeration. This changed when instruments on the Dropner oil platform in the North Sea recorded a 26-meter, 85-foot wave appearing in a sea state, where the significant wave height was only 12 meters, a statistical anomaly that should occur less than once in 10,000 years, according to prevailing wave models. Since then, multiple rogue waves have been instrumentally confirmed, forcing a fundamental reconsideration of ocean wave dynamics and risk modeling for maritime operations. What mechanisms create these marine monsters that defy conventional understanding of how water should behave? Current research suggests rogue waves may form through several distinct processes, including constructive interference, where multiple wave trains intersect, and nonlinear focusing mechanisms that concentrate energy from surrounding waters. Other theories propose interaction between waves and ocean currents, where energy becomes concentrated as waves encounter opposing water flows. Perhaps most intriguing is the growing evidence that rogue waves may result from soliton formation, self-reinforcing solitary wave packets that maintain their shape and velocity while propagating through water with minimal energy loss. These nonlinear wave structures behave more like particles than conventional waves, potentially explaining how rogue waves maintain their height and energy across significant distances. The mathematics describing these phenomena connect to some of the most esoteric areas of physics, including chaos theory and quantum mechanics, suggesting our oceans may demonstrate quantum-like properties at macroscopic scales. Particularly disturbing is the growing evidence that rogue waves may be more common than previously believed, with satellite data suggesting these killers may occur multiple times daily across the global ocean. Their sudden formation and tremendous destructive power make them prime suspects in many unexplained vessel disappearances, particularly those occurring during otherwise moderate weather conditions. Could these hydrodynamic anomalies explain cases where vessels vanish without distress calls, their crews having no time to react before catastrophic structural failure occurs? The ocean's surface occasionally behaves according to mathematical principles we're only beginning to understand, generating killer waves through processes that blend predictable physics with chaotic emergent behavior. These waves represent the visible manifestation of complex mathematics expressing itself through water, equations made flesh, in forms that can destroy the largest human constructions in seconds. Let's explore the unsettling phenomenon of submarine quackers, or bioducks, mysterious sounds recorded by submarine hydrophones since the 1960s that resemble mechanical quacking, repeated in precise patterns. These sounds, initially believed to be generated by Soviet submarine technology, remain classified for decades until researchers eventually connected them to minke whale vocalizations, though questions persist about their unusual regularity and mechanical qualities. What's particularly interesting about this case is how biological sounds can so precisely mimic mechanical ones that military analysts remained convinced of their artificial origin for decades. Could other mysterious underwater sounds currently attributed to unknown technology actually represent biological vocalizations from marine species we haven't fully documented? The ocean's acoustic environment creates persistent challenges for signal analysis, with biological, geological, and anthropogenic sounds often proving difficult to distinguish conclusively. Similar acoustic confusion surrounds the upsweep sound, first detected by NOAA hydrophones in 1991 and continuing intermittently ever since. This sound features a rapidly ascending series of tones that repeat in a predictable pattern for hours or sometimes days at a time. While some researchers suggest upsweep may result from underwater volcanic activity, its remarkable consistency and apparent seasonal variations align more closely with biological patterns than geological processes. Could upsweep represent the communal vocalizations of an unknown deep-sea species that gathers seasonally in the Pacific Ocean? If so, what manner of creature communicates with such mechanical precision, and why has it evaded visual detection despite decades of underwater exploration? Let's examine the mysterious phenomenon of submarine fastwalkers, rapidly moving objects occasionally detected by military sonar systems that travel through water at speeds exceeding 200 knots, far beyond the capabilities of known underwater technology. Naval operators have tracked these anomalous contacts since the development of advanced sonar systems, with declassified Soviet and American naval records documenting similar observations across different ocean regions and time periods. What makes these contacts particularly puzzling is their apparent disregard for water resistance, which should make such velocities physically impossible for any known underwater vehicle or biological organism. Could these acoustic signatures represent previously undocumented physical phenomena rather than actual objects, perhaps unusual propagation effects that create the illusion of extreme speed? Might they indicate underwater plasma formations with electromagnetic properties that allow them to move through water with minimal resistance, similar to supercavitation technology, but occurring naturally? Some researchers propose these contacts might result from interaction between sonar systems and certain marine mammals, creating processing artifacts that appear as high-speed objects. Others suggest they could represent classified breakthrough technology deployed by various naval powers, perhaps utilizing principles like supercavitation to achieve velocities far beyond conventional underwater capabilities. More exotic explanations propose these contacts might represent evidence of non-human technology operating according to physical principles beyond current scientific understanding. Whatever their origin, these anomalous sonar contacts represent one of the most well-documented but least publicly discussed ocean mysteries, with military organizations worldwide maintaining extensive classified records of encounters. The ocean's opacity to electromagnetic radiation makes it the perfect environment for concealing activities from surface observation, whether conducted by conventional human organizations or more exotic intelligences. Let's turn our attention to one of the ocean's most unsettling biological mysteries, the apparent immortality of certain marine organisms that seem to bypass the aging process entirely. Beyond the Turritops istarni jellyfish mentioned earlier, researchers have identified several other marine species with biological immortality, including certain sponges, corals, and bivalves. One ocean quahog, Arctica islenta specimen, nicknamed Ming, was determined to be 507 years old when scientists accidentally killed it during age analysis, meaning it had been alive since before Columbus sailed to America. These extreme lifespans raise profound questions about the biological necessity of aging itself, suggesting death from senescence may be neither inevitable nor necessary from an evolutionary perspective. What genetic mechanisms allow these organisms to repair cellular damage indefinitely, and what might they reveal about the fundamental nature of biological aging? Particularly fascinating is evidence that some biologically immortal marine organisms show no signs of increased cancer risk despite their extended cell division histories, contradicting conventional understanding of mutation accumulation over time. These species appear to have developed extraordinarily efficient DNA repair mechanisms or cancer suppression systems that prevent the cellular dysfunction typically associated with aging. Could studying these marine Methuselahs provide insights into extending human health span or addressing age-related diseases through similar biological pathways? Might the ocean harbor even more extreme examples of biological immortality in deep environments we've barely explored, perhaps organisms that have lived continuously since before humans existed? The evolutionary laboratory of Earth's oceans has apparently solved the problem of aging multiple times through different mechanisms, suggesting biological immortality may be more achievable than conventional medicine assumes. Now let's explore one of the ocean's most visually dramatic mysteries, underwater crop circles and geometric patterns that appear on the seafloor with no clear formation mechanism. Beyond the pufferfish-created patterns mentioned earlier, researchers have documented perfect circles, spirals, and complex geometric formations on the seafloor, in locations ranging from the Baltic Sea to the coast of Western Australia. These patterns sometimes span hundreds of feet in diameter and feature precision that seems inconsistent with random natural processes or known marine animal behavior. Some appear overnight in areas previously documented as featureless sand, while others seem to remain stable for years, despite strong currents that should erase any surface markings. What processes, biological, geological, or otherwise, could create and maintain such precise geometric patterns in underwater environments? While some formations have been attributed to specific causes, like sand dollar colonies creating small-scale patterns through collective movement, many larger-scale geometric seafloor features remain unexplained. Proposed mechanisms include interactions between ocean currents and seafloor topography, creating standing wave patterns that sort sediment into geometric arrangements. Others suggest bacterial or microbial colonies might generate large-scale patterns through collective growth behaviors, similar to the way slime molds can create complex optimization networks. More controversial explanations propose these patterns might represent evidence of intelligent intervention, whether from human technology or more exotic sources. The seafloor's vastness and our limited observation capabilities mean countless such formations likely exist undocumented, with their origins and purposes remaining complete mysteries. Let's examine one of the ocean's most persistent chemical mysteries: underwater lakes of supersaturated hydrogen sulfide that exist within the ocean itself. These deadly pools form when hydrogen sulfide seeps from the seafloor and dissolves in the surrounding water until it reaches saturation, creating distinct boundaries between normal seawater and toxic solution. Marine organisms that stray into these underwater toxic lakes die almost instantly, their bodies preserved by the chemical environment that killed them. What makes these formations particularly disturbing is their movement capability. They can occasionally break free from their seafloor origins and flow through the ocean as cohesive toxic clouds. How do these lethal chemical formations maintain their integrity while moving through surrounding water, potentially threatening marine ecosystems far from their original locations? Scientists have documented hydrogen sulfide clouds moving through deep ocean environments, following underwater landslides or geological disturbances that release their contents. These toxic masses can travel significant distances while maintaining lethal concentration levels, creating mobile kill zones that leave trails of marine casualties in their wake. Some researchers suggest these toxic clouds might explain certain historical mass mortality events among marine life, where large numbers of organisms died simultaneously across extensive areas without apparent cause. Could similar toxic releases on larger scales have played roles in past extinction events, perhaps contributing to the marine die-offs documented in the geological record? The ocean's chemical composition includes lethal elements constantly held in precarious balance, occasionally releasing their deadly potential through mechanisms we've only recently begun to understand. Now let's consider one of the ocean's most mathematically beautiful mysteries, underwater whirlpools that form perfect logarithmic spirals visible from space. These massive vortices can span hundreds of miles in diameter, rotating with precision that mirrors the mathematical patterns found in nautilus shells, galaxy formations, and hurricane structures. What makes these formations particularly fascinating is their persistence. Some maintain their perfect spiral structure for weeks or months despite the chaotic nature of ocean currents and weather patterns. How do these macro-scale fluid dynamics generate and maintain such mathematical precision across time periods and physical scales that should introduce significant chaos and irregularity? Could studying these natural expressions of fluid mathematics provide insights into self-organizing systems across different scientific disciplines, from quantum physics to cosmology? Some oceanographers suggest these perfect spirals emerge from interaction between specific current patterns and the Coriolis effect generated by Earth's rotation. Others propose more complex explanations involving resonance patterns between tidal forces, wind-driven surface currents, and deep ocean thermohaline circulation. Particularly intriguing is evidence that some marine organisms appear to use these spiral current patterns for long-distance migration, suggesting biological recognition of their stable nature. Could these mathematical current formations represent a kind of oceanic infrastructure, reliable energy-efficient pathways that marine life has evolved to recognize and utilize? The ocean occasionally organizes itself according to perfect mathematical principles that transcend the apparent chaos of its surface, revealing deeper patterns of order operating at scales visible only from orbit. Let's explore one of the most unsettling acoustic mysteries in the deep underwater sound channels that can carry certain frequencies thousands of miles with minimal energy loss. These natural acoustic waveguides form at specific depths where temperature and pressure create perfect conditions for sound propagation, essentially functioning as underwater telephone lines across entire ocean basins. What makes these channels particularly remarkable is their efficiency under ideal conditions. A whisper generated in these depth layers could theoretically be detected thousands of miles away with suitable listening equipment. Naval powers worldwide have exploited these natural acoustic features for submarine detection and communication, but they likely served biological functions long before human discovery. Could certain marine species have evolved vocalizations specifically tuned to these sound channels, enabling communication across distances far greater than previously believed possible? Recent research suggests some whale species may coordinate their vocalizations with these channel depths, positioning themselves precisely where their calls will propagate maximum distances. This behavior indicates sophisticated understanding of underwater acoustics that far predates human knowledge of these phenomena, suggesting evolutionary adaptation to the ocean's natural communication infrastructure. Even more intriguing is evidence that certain whale species may be able to tune their vocalizations to different frequency bands, depending on intended communication distance. Could these acoustic adaptations explain certain mysterious ocean sounds that appear to have no nearby source, perhaps representing communications generated thousands of miles from detection points? The ocean contains natural communication networks that existed long before human technology, potentially supporting sophisticated information exchange between widely separated marine organisms through physical principles we've only recently discovered. Now let's examine one of the ocean's most disturbing ecological mysteries, massive marine organism die-offs that occur without clear cause or explanation. Since the 1970s, scientists have documented increasing frequency of these mortality events, where thousands or sometimes millions of marine organisms die simultaneously across large geographical areas. While some cases have been linked to specific causes, like harmful algal blooms or oxygen depletion, many remain unexplained, despite extensive scientific investigation. What's particularly unsettling about these events is their apparent increase in both frequency and scale, suggesting fundamental changes in ocean systems that may signal broader ecological instability. Could these die-offs represent early warning signs of oceanic tipping points, where cumulative stresses push marine ecosystems toward catastrophic state changes? Some researchers propose these mass mortality events might result from previously undocumented pathogens emerging in response to changing ocean conditions, perhaps viruses or bacteria evolving in warming waters. Others suggest they may represent complex interactions between multiple stressors, including chemical pollutants, temperature changes, and altered current patterns that collectively exceed biological tolerance thresholds. Particularly concerning is evidence that some die-offs appear synchronized across different ocean basins, suggesting potential global triggering mechanisms rather than localized causes. Could electromagnetic changes associated with solar activity or Earth's magnetic field occasionally influence marine biology through mechanisms we haven't identified? Might some mass mortality events result from natural phenomena that operate on timescales exceeding our observational history, perhaps cycles that occur only once per century or millennium? The ocean's vastness makes comprehensive monitoring virtually impossible, meaning we likely detect only a small fraction of these events, primarily those occurring near coastlines or shipping routes. This observational bias suggests the true scale and frequency of unexplained marine die-offs may substantially exceed documented cases, with countless events occurring unobserved in remote ocean regions. What ecological signals might these events convey if we could observe them comprehensively, and what might they reveal about the overall health trajectory of Earth's largest ecosystem? The ocean occasionally displays symptoms of distress through these mass mortality events, potentially communicating complex ecological information through patterns we've only partially documented. These die-offs may represent visible manifestations of invisible oceanic changes, biological canaries in the coal mine signaling systemic alterations in marine chemistry, temperature, or circulation patterns. Let's turn our attention to one of the most bizarre oceanic phenomena, immortal jellyfish, Turritopsis dohrnii, a species that possesses the remarkable ability to revert from its mature medusa form back to its juvenile polyp stage when facing environmental stress or physical damage. This biological reset effectively renders the organism immortal under ideal conditions, as it can theoretically repeat this cycle indefinitely to escape death from aging. What makes this adaptation particularly fascinating is its apparent evolutionary uniqueness. Despite the clear survival advantage of biological immortality, relatively few species appear to have developed similar capabilities. Why would such a beneficial trait remain relatively rare in nature when its advantages seem so obvious from a survival perspective? Could there be hidden evolutionary costs to biological immortality that balance its apparent benefits, perhaps increase vulnerability to certain pathogens or reduce adaptive capacity? Scientists have documented this jellyfish's transformation process through cellular transdifferentiation, where specialized cells transform into different cell types rather than reverting to stem cell states. This mechanism differs fundamentally from typical cellular regeneration, representing a more complete biological reset that effectively creates a new young organism from an aging one. What's particularly intriguing is evidence suggesting elements of this cellular reprogramming capability may exist in other species, including humans, though typically locked behind developmental barriers. Could studying these immortal jellyfish provide insights into human aging processes, or even therapeutic approaches to age-related diseases? Might the ocean harbor other examples of biological immortality we haven't yet discovered, perhaps operating through entirely different cellular mechanisms? Now let's examine one of the ocean's most enduring navigation mysteries, the phenomenon of unexplained compass deviations that persist in certain marine regions, despite modern navigational technology. Beyond the Bermuda Triangle, several ocean regions worldwide feature documented magnetic anomalies where compass readings become unreliable and electronic equipment occasionally malfunctions. These areas include the Devil's Sea near Japan, the South Atlantic Anomaly, and certain regions of the North Sea, all featuring similar reports from both civilian and military vessels. What's particularly interesting about these locations is their apparent stability across centuries of observation, suggesting they represent persistent geophysical features rather than temporary phenomena. What geological or geomagnetic characteristics might these regions share that could explain their documented effects on navigational equipment? Some geophysicists propose these anomalies might result from unusual concentrations of magnetic minerals in the ocean floor, potentially related to ancient meteorite impacts or unique volcanic formations. Others suggest interactions between Earth's magnetic field and specific ocean current patterns rich in dissolved minerals might generate localized electromagnetic disturbances. More exotic explanations propose crystalline structures deep within Earth's crust might occasionally interact with solar radiation to create temporary magnetic disturbances in certain ocean regions. Could these magnetic anomalies indicate deeper structural features within Earth that remain undetected by current geological survey methods? The ocean sometimes reveals the presence of invisible forces through their effects on human technology, pointing toward geophysical processes operating beyond our current understanding. Let's explore one of the ocean's most visually striking mathematical phenomena, beaches that naturally form perfect logarithmic spiral shapes, despite constant wave action that should disrupt such precision. These spiral beaches, including famous examples like Playa de Gulpiyuri in Spain and Dalton Point in Australia, maintain their mathematical curves with remarkable consistency despite being composed of loose sand constantly reshaped by waves. What makes these formations particularly fascinating is their mathematical perfection. They follow the same logarithmic spiral equation found in nautilus shells, galaxy formations, and certain plant growth patterns. How do these precise mathematical forms emerge and persist in environments characterized by chaotic forces like wave action, wind patterns, and tidal shifts? Could these spiral beaches demonstrate fundamental principles about self-organizing systems that transcend their specific physical manifestations? Some geomorphologists suggest these spiral formations result from complex interactions between wave refraction patterns, sediment characteristics, and coastal topography. Others propose more fundamental explanations involving energy minimization principles, where natural systems spontaneously adopt configurations that optimize energy distribution across available space. Particularly intriguing is evidence that these spiral beaches often show remarkable stability following major storms, rapidly returning to their mathematical form, despite temporary disruption. Could these natural formations represent attractors in chaos theory, preferred states toward which physical systems naturally evolve, regardless of temporary perturbations? The ocean occasionally creates visible mathematics through purely physical processes, suggesting deeper connections between abstract numerical relationships and the material world than we typically recognize. Now let's consider one of the ocean's most unsettling temporal mysteries: underwater archaeological sites that suggest human civilization may be far older than conventional history acknowledges. Submerged structures worldwide, including the Yonaguni Monument near Japan, the Gulf of Cambay ruins off India, and numerous sites in the Mediterranean, feature architectural characteristics that would have required construction during the last ice age, when sea levels were significantly lower. What makes these sites particularly challenging to conventional archaeology is their apparent sophistication during periods when humans were supposedly living as hunter-gatherers without complex building technology. Could these underwater ruins represent evidence of advanced maritime civilizations that existed thousands of years before the accepted timeline for the development of urban society? What catastrophic events might have consigned these coastal civilizations to the ocean floor, and what knowledge was lost when their builders disappeared beneath the advancing seas? Some marine archaeologists suggest these structures may represent natural formations, misinterpreted as artificial, noting that certain geological processes can create features resembling walls, roads, and platforms. Others maintain that specific characteristics, including precise angles, consistent measurements, and apparent tool marks, indicate human modification beyond what natural processes could produce. Particularly intriguing are underwater structures that align with celestial events like solstices or equinoxes, suggesting potential astronomical knowledge among their builders. Could rising sea levels following the last ice age have submerged extensive coastal civilizations, preserving their remains in oxygen-poor environments where decay occurs much more slowly than on land? The ocean floor potentially contains archaeological evidence that could fundamentally revise our understanding of human history, preserved in conditions inaccessible until the development of modern diving technology. Let's explore one of the ocean's most beautiful and terrifying predatory adaptations: marine bioluminescence used specifically to lure prey to their deaths. Beyond the familiar anglerfish with its glowing lure, numerous deep-sea organisms have evolved sophisticated light-producing mechanisms designed specifically to attract prey into striking range. What makes these adaptations particularly remarkable is their precise mimicry of light patterns that would appear attractive or non-threatening to potential prey species. Some predatory fish produce light patterns that exactly simulate the bioluminescent displays of smaller, harmless species, essentially creating visual bait that draws curious prey directly to waiting jaws. Others generate light displays that mimic mating signals of potential prey, exploiting reproductive instincts to create deadly attractions through evolutionary deception. Perhaps most sophisticated are cooperative hunting strategies documented among certain deep-sea organisms, where multiple individuals coordinate their bioluminescent displays to herd prey toward waiting predators. These complex light-based hunting behaviors suggest levels of coordination and potentially even rudimentary communication among species, typically considered primitive. What cognitive capabilities might these cooperative hunting strategies indicate, and how do organisms with relatively simple nervous systems coordinate such sophisticated behaviors? Could deep-sea environments, with their reliance on self-generated light rather than vision based on ambient illumination, have selected for types of intelligence fundamentally different from those that evolved in sunlit waters? The ocean's darkness has spawned evolutionary arms, races focused on light itself, creating biological deception systems of remarkable sophistication, operating in an environment where visibility extends only as far as self-generated illumination allows. Now let's turn our attention to one of the most puzzling oceanographic phenomena: underwater rivers that flow along the seafloor with distinct banks, currents, and even waterfalls, where they cascade over submarine cliffs. These underwater rivers form when water with different density, usually due to higher salinity or temperature differences, flows along the seafloor as a distinct layer within the larger ocean. What makes these formations particularly striking is their visual similarity to terrestrial rivers, complete with meandering channels, tributary systems, and rippled sandy bottoms created by current flow. Divers who visit these underwater rivers report the uncanny experience of seeming to fly above riverbanks, watching particulate matter flow like silt along defined channels through otherwise clear water. How do these hydrological features maintain their distinct boundaries while flowing through surrounding water, sometimes for hundreds of miles across the ocean floor? Scientists have documented these underwater rivers flowing at speeds up to 4 miles per hour, carrying sediment and nutrients through the ocean in patterns that significantly influence deep-sea ecology. The largest discovered so far flows along the Black Sea floor, carrying a volume of water comparable to many prominent terrestrial rivers, such as the Rhine or Seine. Most remarkable are underwater waterfalls, where denser water cascades over submarine cliffs and visible curtains flowing through the surrounding ocean. Could these underwater hydrological systems play previously unrecognized roles in ocean chemistry and nutrient cycling, transporting materials through the water column in patterns we've only begun to document? The ocean contains parallel versions of virtually every terrestrial landscape feature, expressed through density differences rather than the air-water boundary that defines similar features on land. Let's explore one of the ocean's most unsettling sensory adaptations, the electroreception capabilities of certain marine organisms that allow them to detect the faintest electrical signals, including the neural activity of hidden prey. Sharks can detect electrical fields as weak as 5 nanovolts per centimeter, equivalent to detecting a standard LA battery connected to electrodes placed 1,000 miles apart. This extraordinary sensitivity allows them to locate prey buried completely beneath seafloor sediments, detecting only the minute electrical signals generated by heartbeats or muscle contractions. What's particularly remarkable about this sense is its fundamentally different nature from human perception. These animals experience their environment through an electromagnetic dimension entirely absent from human sensory experience. Could this alternative perceptual reality reveal aspects of the physical world that remain invisible to human senses and instruments calibrated to human perception? Some research suggests electroreceptive marine organisms may detect not just nearby electrical sources, but potentially Earth's geomagnetic field itself, using this information for long-distance navigation. Other studies indicate certain species may communicate through controlled bioelectric signals, creating a form of electromagnetic language undetectable without specialized equipment. Particularly intriguing is evidence that some marine organisms appear sensitive to extremely low-frequency electromagnetic signals that can propagate through seawater for enormous distances. Could these creatures detect electromagnetic phenomena generated by geological processes deep within the Earth, perhaps providing early warning of seismic events through signals humans can only measure with sophisticated instruments? The ocean contains perceptual worlds operating according to sensory principles, fundamentally different from terrestrial experience, potentially revealing aspects of reality that remain literally unimaginable to land-dwelling organisms. Now let's examine one of the ocean's most mysterious mathematical phenomena, the perfect hexagonal columns of underwater basalt formations that form through purely physical processes without biological intervention. These remarkably precise geometric columns form when volcanic lava cools underwater under specific conditions, causing the rock to contract and fracture into perfectly hexagonal pillars. What makes these formations mathematically fascinating is their demonstration of how simple physical processes can generate perfect geometric forms without any biological or intelligent guidance. The hexagonal pattern represents the most efficient configuration for minimizing energy during cooling contraction, essentially the same mathematical solution that honeybees discover when building their combs. How do basic laws of thermodynamics and material science create such precise mathematical patterns spontaneously in cooling rock? This geometric efficiency emerges naturally from physical processes rather than conscious calculation, demonstrating how fundamental mathematical principles express themselves through matter under certain conditions. Similar geometric patterns appear throughout nature at various scales, from microscopic crystal structures to massive geological formations spanning miles. Could studying these natural expressions of geometric principles provide insights into mathematical laws that transcend their specific physical manifestations? Might the same underlying principles that generate hexagonal cooling patterns in underwater basalt also inform optimal organization in completely different systems, from biological cell structures to cosmic arrangements of matter? The ocean occasionally preserves perfect geometric forms that suggest deeper mathematical order underlying apparently chaotic natural processes, visible evidence of how physical laws generate mathematical precision through simple interactions over time. Let's consider one of the ocean's most perplexing ecological mysteries, the synchronized spawning behavior of certain coral species across vast geographical distances. During specific full moon phases each year, coral reefs separated by hundreds or even thousands of miles release their reproductive cells simultaneously, often within minutes of each other, despite having no apparent communication mechanism. What makes this synchronization particularly baffling is its precision across different species and geographical locations, suggesting coordination mechanisms that transcend individual reef systems. How do organisms with no centralized nervous system or apparent long-distance communication capabilities achieve such remarkable temporal alignment across oceanic scales? Could these corals be responding to environmental signals so subtle they remain undetected by our scientific instruments, perhaps related to lunar gravitational effects or electromagnetic field fluctuations? Some marine biologists suggest this synchronization might result from evolutionary adaptation to lunar cycles, affecting tidal patterns and light levels, with each coral species independently evolving similar responses. Others propose more direct coordination mechanisms, including the possibility that chemical signals released by early spawning individuals might trigger chain reactions across reef systems. Particularly intriguing is evidence that artificial light pollution can disrupt these spawning events, suggesting the corals may respond primarily to specific light wavelengths or intensities associated with lunar cycles. Could studying these natural synchronization processes provide insights into self-organizing systems across different scientific disciplines, from neuroscience to computer engineering? The ocean occasionally demonstrates emergent coordination that appears to transcend individual organisms, suggesting communication networks operating through chemical, electromagnetic, or gravitational pathways we've barely begun to investigate. Now let's explore one of the ocean's most unsettling geological mysteries: underwater sinkholes known as blue holes that plunge hundreds or even thousands of feet vertically from shallow coastal waters. These perfect cylindrical shafts form when rainwater erodes limestone over millennia, creating enormous vertical caves that later become submerged due to rising sea levels. What makes these formations particularly mysterious is their often completely isolated nature. Many blue holes show no apparent connection to surrounding water circulation patterns, creating stagnant, oxygen-depleted environments with unique chemical properties. The most famous example, the Great Blue Hole off Belize, measures approximately 1,000 feet across and descends 400 feet into darkness, with perfectly vertical walls creating the visual impression of a gigantic drain in the ocean floor. What biological adaptations allow organisms to survive in these isolated underwater caves, with their extreme chemical conditions and minimal energy inputs? Exploration of blue holes has revealed surprising archaeological and paleontological findings, including perfectly preserved human remains and extinct animal species, dating back thousands of years. The oxygen-poor environment within many blue holes prevents normal decomposition processes, creating natural preservation conditions for organic materials that would quickly deteriorate in typical marine environments. Some blue holes contain distinct water layers with dramatically different chemical properties, including anoxic zones where hydrogen sulfide creates water that would be immediately toxic to most marine organisms. Could these isolated underwater environments preserve evidence of historical events or extinct species that would have decomposed in normal ocean conditions? Blue holes represent natural time capsules within the ocean, preserving materials and potentially organisms in conditions that have remained stable for thousands of years, while the surrounding marine environment has undergone significant changes. Let's turn our attention to one of the ocean's most persistent acoustic mysteries: unexplained low-frequency humming sounds detected by scientific instruments worldwide. Since the 1990s, specialized hydrophones have recorded continuous low-frequency sounds emanating from various ocean regions with no clear source identification. The most famous, known as the Pacific Ocean hum, consists of a steady drone at approximately 57 Hz that continues year-round and can be detected thousands of miles from its apparent source region. What makes these acoustic phenomena particularly baffling is their persistence across decades of monitoring and their apparent independence from known geological or biological processes. Could these continuous humming sounds represent previously undocumented geological processes operating on scales too large or subtle for direct observation? Some researchers suggest these acoustic signatures might result from interaction between ocean currents and specific seafloor topography, essentially creating enormous natural pipe organs. Others propose more exotic sources, including resonance effects from Earth's continuous seismic vibrations, or even large-scale thermal convection processes within the planet's mantle. Particularly intriguing is evidence that some of these humming sounds show slight frequency variations corresponding with seasonal changes, suggesting potential connections to large-scale oceanographic processes. Could these persistent acoustic signatures represent fundamental voices of oceanic or planetary processes operating at scales and timeframes that exceed human observational history? The ocean's mysterious background sounds potentially represent acoustic manifestations of planetary processes we've barely begun to understand, continuous transmissions from Earth's geological systems, operating beyond human perceptual frameworks. Now let's examine one of the ocean's most disturbing deep-sea adaptations, the transparent heads of certain fish species that allow them to look directly upward through their own skulls. The barrelly fish, Macropina microstoma, features a completely transparent cranium filled with fluid, allowing its tubular eyes to rotate within a protected dome, while providing 360-degree visibility. This extraordinary adaptation enables the fish to detect the silhouettes of potential prey against the faint sunlight filtering down from the surface, while simultaneously monitoring bioluminescent signals from below. What evolutionary pressures could produce such a dramatic anatomical innovation, essentially creating a living submarine periscope with glass-like structural components? How does this transparent tissue maintain both optical clarity and structural integrity under the crushing pressures of the deep ocean environment? Marine biologists suggest this remarkable adaptation evolved in response to the unique challenges of middle-depth ocean environments, where organisms must simultaneously detect prey above and threats below in near-darkness conditions. The transparent head essentially functions as a biological periscope, allowing the fish to maintain a hydrodynamic body position while visually monitoring a much larger environmental sphere. Perhaps most impressive is the fish's ability to rotate its tubular eyes within the transparent dome, directing its high-sensitivity vision precisely where needed without moving its entire body. Could similar optical adaptations exist in other deep-sea organisms we haven't yet documented, perhaps operating according to visual principles that transcend conventional understanding of biological optics? The evolutionary pressures of deep ocean environments have produced sensory adaptations that would seem like science fiction if we hadn't directly observed them, suggesting the potential for even more extraordinary biological innovations in ocean regions we've barely explored. Let's explore one of the ocean's most beautiful mathematical mysteries, the spiral swimming patterns of certain marine organisms that follow perfect logarithmic curves, identical to those found in nautilus shells and spiral galaxies. When hunting or searching, some shark species trace perfect logarithmic spirals through the water, their paths precisely matching mathematical formulas that appear throughout nature at vastly different scales. What makes these movement patterns particularly fascinating is their mathematical precision. These animals create perfect spirals without any apparent calculation, suggesting fundamental connections between biological behavior and abstract mathematical principles. How do these organisms encode such complex mathematical patterns in their nervous systems without any computational capacity for the underlying calculations? Could these spiral patterns represent optimal search strategies that emerge through evolutionary processes, essentially discovering mathematical efficiency through natural selection? Some biophysicists suggest these spiral movements represent emergent properties of simple sensory rules, where straightforward neurological responses to environmental stimuli naturally generate complex mathematical patterns. Others propose more fundamental connections between spiral mathematics and efficient search algorithms, noting that logarithmic spirals mathematically optimize the coverage area while minimizing energy expenditure. Particularly intriguing is evidence that similar spiral search patterns appear across numerous unrelated marine species, suggesting independent evolutionary discovery of the same mathematical solution. Could these convergent mathematical behaviors reveal fundamental truths about optimal pattern formation in physical systems, potentially applicable across different scientific disciplines? The ocean occasionally offers glimpses of pure mathematics expressed through living organisms, suggesting deeper connections between abstract numerical relationships and biological processes that shape behavior across evolutionary timescales. Now let's consider one of the ocean's most disquieting acoustic phenomena, the abrupt silencing of all marine noise in certain regions just before major seismic events. Hydrophone networks monitoring ocean soundscapes have occasionally documented sudden cessation of all biological sounds, from whale calls to fish vocalizations, hours or sometimes days before major earthquakes occur in nearby regions. This acoustic silence represents a dramatic deviation from normal ocean soundscapes, which typically feature continuous biological chorus across multiple frequency bands. What sensory capabilities might allow marine organisms to detect precursor signals of seismic events long before human instrumentation can identify them? Could marine life perceive subtle changes in electromagnetic fields, water chemistry, or pressure waves that precede major geological events, providing early warning systems evolved over millions of years of exposure to undersea seismic activity? Some researchers suggest these pre-seismic silences might result from marine organisms detecting increased levels of dissolved gases or subtle temperature changes associated with pre-earthquake activity along fault lines. Others propose more exotic detection mechanisms, including sensitivity to fluctuations in Earth's local magnetic field that often precede major seismic events. Particularly intriguing is evidence that certain shark species exhibit unusual behavior patterns days before underwater volcanic eruptions, including abandonment of traditional territories and movement toward deeper waters. Could these behavioral responses to imperceptible environmental changes represent biological earthquake prediction systems far more sensitive than our most advanced technologies? The ocean's inhabitants may perceive aspects of Earth's geophysical processes entirely invisible to human senses, their behaviors potentially offering early warning signals of geological events. If we learn to properly interpret them, let's examine one of the ocean's most haunting visual mysteries: underwater light phenomena that defy conventional explanation, sometimes called underwater auroras. Deep-sea submersible crews and specialized cameras have occasionally documented luminous curtain-like formations in deep ocean environments resembling atmospheric aurora borealis, but occurring hundreds or thousands of feet underwater. Unlike typical marine bioluminescence, which appears as distinct points or brief flashes of light, these phenomena create flowing curtains of illumination that persist for minutes or sometimes hours. What makes these light displays particularly puzzling is their appearance in depths and patterns inconsistent with known bioluminescent organisms or processes. Could these underwater light curtains represent previously undocumented interactions between seawater and electromagnetic fields, perhaps similar to the processes that create atmospheric auroras but adapted to the marine environment? Some oceanographers suggest these phenomena might result from bioluminescent bacteria or microorganisms, responding collectively to specific environmental triggers, creating synchronized light displays across large areas. Others propose more exotic mechanisms, including the possibility that certain mineral-rich seawater regions might occasionally interact with Earth's magnetic field to produce light through processes similar to electroluminescence. Particularly intriguing are observer reports describing these light formations appearing to respond to nearby vessels or equipment, sometimes seeming to approach or follow human observers. Could these apparent responses represent reactions to electromagnetic fields generated by observation equipment rather than conscious behavior, perhaps indicating sensitivity to electrical or magnetic disturbances? The ocean's light phenomena occasionally transcend our current explanatory frameworks, suggesting interactions between physical processes and potentially biological systems that generate visual effects without clear mechanisms. Now let's explore one of the ocean's most persistent chemical mysteries: underwater formations known as brinicles or ice fingers of death that extend from sea ice toward the seafloor, freezing everything they touch. These eerie structures form when super-cold brine solutions leak from sea ice and sink through slightly warmer seawater, creating a flowing column of freezing liquid that solidifies surrounding water as it descends. What makes these formations particularly dramatic is their deadly effect on marine organisms. Anything touched by a descending brinicle freezes almost instantly, creating macabre underwater sculptures of flash-frozen marine life. The completed structures resemble upside-down icicles extending from sea ice to the seafloor, sometimes reaching heights of several feet and creating ice pools where they contact the ocean bottom. How do these freezing brine columns maintain their integrity while flowing through slightly warmer surrounding water, creating directed paths of freezing death rather than simply dissipating into the ocean? Scientists explain that brinicles form through a delicate balance between temperature, salinity, and flow rate, creating self-reinforcing tubes of ice that channel the descending super-cold brine. As the initial brine solution begins to freeze surrounding water, it creates an insulating ice tube that protects the continuing flow of super-cold liquid from dissipating into the warmer ocean. This self-reinforcing process allows the growing ice tube to extend farther and farther downward, essentially becoming a specialized organ of the sea ice, reaching toward the seafloor. Could similar self-organizing processes explain other mysterious ocean structures, perhaps operating through different physical principles, but similarly creating order from apparently chaotic conditions? These ice fingers of death represent visible manifestations of complex thermodynamic processes, operating at the boundary between solid and liquid states, creating deadly but mathematically beautiful structures through purely physical mechanisms. Let's turn our attention to one of the ocean's most enduring paleontological mysteries, the megalodon, an enormous prehistoric shark that dominated ancient oceans, but whose true size and appearance remain subjects of scientific debate. While conventional estimates suggest this extinct predator reached lengths of approximately 60 feet, some researchers propose it may have grown substantially larger based on certain fossil evidence. What makes this creature particularly mysterious is the nature of its fossil record. As a cartilaginous fish, megalodons left behind primarily teeth rather than complete skeletons, forcing scientists to extrapolate their full dimensions. These teeth, some measuring over 7 inches in length, suggest a predator of almost unimaginable proportions, with bite forces estimated to exceed 40,000 pounds per square inch. Could megalodons have grown even larger than current estimates suggest, perhaps explaining certain massive bite marks found on prehistoric whale fossils that exceed the dimensions of known predators? Some paleontologists suggest megalodons may have exhibited greater sexual dimorphism than modern sharks, with females potentially growing significantly larger than males. This dimorphism could explain the wide variation in size estimates derived from different fossil specimens, with the largest teeth potentially coming exclusively from mature females. Particularly intriguing is the question of when megalodons truly went extinct, while conventional science places their disappearance at approximately 3.6 million years ago. Some researchers suggest isolated populations might have persisted in deep ocean environments into more recent times. Could megalodon populations have survived in deep ocean trenches beyond their supposed extinction date, perhaps explaining some historical accounts of enormous sharks encountered by early mariners? The ocean's fossil record remains highly incomplete due to the challenges of preserving and recovering remains from deep marine environments, leaving room for significant revisions to our understanding of prehistoric ocean ecosystems. Now let's examine one of the ocean's most persistent human mysteries, the fate of Percy Fawcett's lost expedition that vanished while searching for a legendary lost city in the Amazon basin in 1925. While primarily a land-based expedition, this mystery connects to oceanic exploration through the surprising discovery of artifacts, apparently from Fawcett's expedition, found by deep-sea fishermen off Brazil's coast nearly 60 years after his disappearance. These items, including a compass bearing Fawcett's initials and a leather map case containing expedition documents, were allegedly recovered from fishing nets at depths exceeding 200 feet in locations over 100 miles from shore. How could personal effects from a land-based expedition find their way to deep ocean locations so far from the expedition's last known position in the Amazon interior? Could these findings suggest alternative fates for the expedition beyond the conventional assumption that Fawcett and his companions perished in the jungle? Some researchers suggest these oceanic discoveries might indicate Fawcett's expedition actually reached the Atlantic coast before meeting their end, perhaps attempting to return by sea rather than retracing their jungle route. Others propose more exotic explanations, including the possibility that native populations who encountered the expedition might have eventually traded or transported their possessions toward coastal regions. Particularly intriguing is the condition of the recovered items, which reportedly showed preservation consistent with long-term submersion in deep ocean environments rather than exposure to tropical jungle conditions. Could these artifacts represent evidence of an entirely different expedition fate than conventional historical accounts suggest, perhaps indicating Fawcett's party reached locations far from their presumed disappearance site? The ocean occasionally returns physical evidence that challenges established historical narratives, preserving materials that might otherwise have decomposed in terrestrial environments, and revealing connections between seemingly unrelated mysteries. Let's explore one of the ocean's most beautiful and deadly chemical mysteries, the nature and origin of Milky Seas, vast regions of ocean surface that glow with an eerie white or blue-white bioluminescence visible from orbit. Unlike typical marine bioluminescence, which manifests as brief flashes or sparkling patterns when water is disturbed, Milky Seas create continuous, uniform illumination that transforms night into twilight across enormous ocean regions. This phenomenon has been documented in maritime records for centuries, with the earliest reliable account appearing in Jules Verne's 20,000 Leagues Under the Sea, based on actual sailor reports. Modern satellite confirmation of Milky Seas began in 2005, when NASA instruments captured an event in the Indian Ocean that illuminated approximately 6,200 square miles of water surface for 3 consecutive nights. What biological or chemical processes could possibly generate bioluminescence on such massive scales, maintaining continuous light production rather than the brief flashes typical of most light-producing marine organisms? The leading scientific explanation attributes Milky Seas to luminous bacteria, Vibrio Harvey colonizing microalgae blooms, creating a biological light system operating on industrial scales. Yet questions remain about the triggering mechanisms that cause these bacteria to illuminate simultaneously across thousands of square miles, maintaining synchronization for multiple nights. Some researchers suggest atmospheric electrical phenomena might provide the triggering mechanism, perhaps through subtle changes in water surface charge during certain weather conditions. Others propose that pressure waves from seismic events might synchronize bacterial light production across vast areas through mechanical stimulation. These explanations remain speculative, as scientists have directly sampled active Milky Seas only once, during a 1985 research vessel encounter in the Arabian Sea. Perhaps most unsettling about Milky Seas is their apparent intelligence. Many observer reports describe the illumination responding to vessel movement, sometimes appearing to track ships or aircraft passing overhead. While likely representing the interaction between vessel wakes and bioluminescent organisms, these descriptions from experienced mariners suggest behavior patterns more complex than simple mechanical stimulation. Could communal bacterial colonies develop emergent properties that mimic intentional response to environmental stimuli when operating on massive scales? Might oceanic bioluminescence represent a form of communication between microorganisms operating on spatial and temporal scales we struggle to recognize as meaningful? The ocean's light shows may represent biological communication systems whose patterns and purposes remain entirely opaque to human understanding. Now let's examine one of the most persistent maritime archaeological mysteries, the true fate of the HMS Terror and HMS Erebus, British exploration vessels that disappeared during the ill-fated Franklin expedition to the Arctic in 1845. After vanishing without trace for over 150 years, despite numerous search efforts, the wreckage of both ships was finally discovered in the 2010 in locations that contradicted many historical theories about the expedition's end. What makes these discoveries particularly puzzling is the condition and position of the wrecks. Both vessels appear to have been deliberately anchored in their final positions, rather than being crushed or sunk by ice, as historically assumed. Even more mysteriously, items aboard the ships were arranged in patterns, suggesting the crews had abandoned the vessels systematically rather than in panic, despite historical evidence of catastrophic conditions. What actually happened to the Franklin expedition in its final days, and why did the archaeological findings contradict many elements of the historical narrative constructed from limited evidence recovered in the 19th century? Perhaps most puzzling is evidence that at least one of the ships appears to have been recrewed and sailed after its initial abandonment, suggesting some expedition members may have returned to the vessels after initially leaving them. This contradicts the conventional narrative that the crews died while attempting to walk south after abandoning their icebound ships. Underwater archaeology revealed both vessels were locked in a death grip of Arctic ice when they sank, preserved in near-perfect condition by the frigid waters for over 170 years. Could the Franklin expedition's final chapter involve survival scenarios more complex than the historical record suggests, perhaps including multiple abandonment and return cycles as conditions changed? The ocean preserved these vessels and their contents in conditions that allow modern archaeology to challenge historical narratives, demonstrating how underwater environments can maintain evidence lost in terrestrial contexts. Let's explore one of the ocean's most beautiful but deadly mysteries, underwater caves with perfectly preserved human remains that appear frozen in time from the moment of death. In cenotes, natural sinkholes throughout Mexico's Yucatan Peninsula, divers have discovered the remains of ancient Maya individuals who apparently drowned in these sacred waters thousands of years ago. What makes these discoveries particularly haunting is their preservation state. The cave's unique chemical properties have maintained soft tissues, clothing, and even facial expressions across millennia. Some remains appear caught in their final moments, with body positions and expressions suggesting they were conscious as they drowned in these sacred waters. What cultural or religious practices led these individuals to these underwater caves, and what do their final moments reveal about ancient Maya beliefs about death and the afterlife? Archaeological evidence suggests many of these individuals represent sacrificial victims, deliberately placed in cenotes as offerings to Maya rain deities who were believed to reside in these underground waters. Others appear to represent accident victims, perhaps individuals who entered the caves for religious purposes but became disoriented in the labyrinthine underwater passages. Particularly unsettling are remains found in positions suggesting they struggled to find air pockets or exits as they drowned, their final moments of panic preserved for thousands of years by the cave's preservative environment. Could these ancient remains provide insights into psychological responses to drowning that might inform modern water safety and rescue techniques? The ocean and its connected waterways occasionally preserve human remains in conditions that allow us to witness final moments across vast temporal distances, creating emotional connections with individuals who died thousands of years before our birth. Now, let's turn our attention to one of the ocean's most unsettling biological mysteries, marine organisms with collective intelligence capabilities that suggest consciousness may exist across distributed biological networks rather than centralized brains. Certain colonial marine organisms, including some jellyfish and siphonophores, demonstrate coordinated behaviors far exceeding the capabilities of their simple neural structures when considered individually. The Portuguese man-o'-war, technically a colonial organism composed of specialized individual animals rather than a single creature, exhibits hunting strategies and defensive responses, suggesting intelligence emerging from its collective structure. What makes these organisms particularly fascinating is their challenge to conventional understanding of consciousness as necessarily located within centralized brain structures. Could these colonial entities represent alternative evolutionary paths to intelligence, where cognition emerges from networked simple components rather than increasingly complex, centralized processors? Marine biologists have documented these colonial organisms making apparently strategic decisions about hunting techniques, navigation routes, and predator avoidance that seem to exceed the computational capabilities of their individual components. Some colonial species demonstrate learning capabilities, adapting their behaviors based on past experiences despite lacking any centralized memory storage system, analogous to vertebrate brains. Particularly intriguing is evidence that information can propagate through these colonial networks at varying speeds, depending on its apparent importance, suggesting prioritization mechanisms typically associated with more complex nervous systems. Could studying these distributed marine intelligences provide insights into alternative models of consciousness that might inform artificial intelligence development or our understanding of emergent properties in complex systems? The ocean harbors forms of intelligence that challenge our anthropocentric definitions of consciousness, suggesting cognition may arise through multiple evolutionary pathways beyond the centralized brain structures that dominate terrestrial evolutionary history. Let's examine one of the ocean's most persistent cartographic mysteries, the appearance of phantom islands on maritime charts throughout history that were mapped, named, and reported by multiple reliable observers, yet proved non-existent when deliberately sought. From Sandy Island in the Coral Sea, removed from maps only in 2012, to Bermeja in the Gulf of Mexico, which appeared on maps for 500 years before being officially undiscovered. Numerous substantial landmasses have populated ocean charts, despite eventually proving imaginary. What makes these phantom islands particularly puzzling is their documentation by experienced navigators, using increasingly sophisticated equipment, often with multiple independent sightings across different voyages. How could professional mariners, trained in precise observation and navigation, repeatedly document substantial islands that didn't actually exist? Could these phantom islands represent temporary phenomena rather than permanent landmasses, perhaps volcanic formations that emerged briefly before subsiding below the waves? Some historians suggest navigational errors explain many phantom islands, with measurements taken during poor visibility or from great distances, creating false impressions of land. Others propose more unusual explanations, including the possibility that some reported islands might have been massive floating objects of biological origin, perhaps enormous algae mats or even unknown marine organisms of exceptional size. Particularly intriguing are phantom islands, reported by multiple vessels at the same coordinates over periods spanning decades or centuries, suggesting phenomena more persistent than simple navigational errors. Could some phantom islands represent optical illusions created by specific atmospheric conditions interacting with ocean features, perhaps similar to superior mirages that can make distant objects appear elevated above the horizon? The ocean occasionally creates visual deceptions that persist across generations of maritime charts, revealing how perception and reality can diverge even among the most experienced professional observers. Now let's explore one of the ocean's most dramatic acoustic mysteries: underwater explosions that occur with no visible source or explanation. Submarine crews and oceanographic research vessels occasionally detect powerful explosive sounds from deep water that register on multiple hydrophones, yet correlate with no known human activity or geological event. These sounds often feature acoustic signatures resembling detonations, with sharp pressure rises followed by characteristic pressure decay patterns consistent with explosion physics. Yet investigation reveals no debris, no military exercises, no seismic activity, nothing that explains auditory events powerful enough to be detected hundreds of miles away. What natural or artificial processes could generate explosion-like acoustic signatures in deep ocean environments while leaving no other evidence of their occurrence? Some researchers suggest these sounds might result from massive methane bubble releases from seafloor deposits, creating powerful acoustic events as large gas volumes rapidly expand during ascent. Others propose underwater landslides or sudden collapse of submarine geological features might generate the acoustic signature of explosions without surface manifestation. More exotic explanations include cavitation events, the formation and immediate collapse of vacuum bubbles in water due to pressure differentials, occurring on scales large enough to generate explosion-like acoustics. Could the immense pressure differentials in deep ocean environments create natural hydrodynamic phenomena that mimic artificial explosions through purely physical processes? The ocean's acoustic environment remains among its least understood aspects, with sound propagation affected by temperature layers, salinity gradients, and pressure variations that create complex transmission paths for mysterious signals. Let's examine one of the ocean's most unsettling cognitive mysteries: the nature and extent of cetacean intelligence, and the possibility that whales and dolphins might possess forms of consciousness comparable to or exceeding human cognition in certain domains. The brains of sperm whales contain approximately 5 times more spindle neurons, cells associated with advanced cognition, emotional processing, and social awareness, than human brains, despite evolving along entirely separate evolutionary pathways. What makes this parallel neurological development particularly fascinating is its suggestion that certain aspects of advanced intelligence may represent inevitable evolutionary adaptations to complex social environments rather than unique human traits. Could these marine mammals possess forms of intelligence structured so differently from human cognition that we lack the frameworks to recognize or measure them appropriately? Might cetaceans have developed advanced capabilities in sensory domains humans can barely comprehend, such as their sophisticated acoustic imaging systems that essentially allow them to see through sound? Marine biologists have documented complex cultural traditions among certain whale populations, including distinctive vocalizations and behaviors transmitted through social learning rather than genetics. Some cetacean species demonstrate tool use, problem-solving capabilities, self-recognition, and apparent awareness of death that suggest cognitive capabilities previously considered unique to primates. Particularly intriguing is evidence that certain whale species may communicate through specialized vocalizations that function more like holistic concepts than the sequential symbolic language humans employ. Could cetacean communication represent fundamentally different approaches to information exchange, perhaps transmitting complex multidimensional concepts through acoustic structures humans perceive merely as songs? The ocean potentially harbors intelligence that evolved along entirely different pathways from terrestrial cognition, perhaps achieving advanced capabilities in domains where human cognition remains limited by our primarily visual and symbolic processing systems. And now, as we conclude our journey through the ocean's darkest mysteries, take a moment to consider the vastness of what remains unknown beneath those deceptively tranquil surfaces. The mysteries we've explored represent merely the visible edge of the ocean's secrets, the anomalies, phenomena, and creatures that have briefly intersected with human observation or instrumentation. Beyond these documented enigmas lie countless others occurring daily in abyssal environments human eyes have never witnessed, operating according to biological, chemical, and physical principles we may not yet comprehend. The true nature of our oceans remains largely beyond our understanding, a parallel world operating according to ancient rules that predate human existence by billions of years. What lies in those unplumbed depths, moving through eternal darkness beyond human knowledge or comprehension? Perhaps the ocean's greatest mystery isn't any specific phenomenon, but rather its fundamental alienness, the fact that Earth's largest habitat remains more mysterious to us than the surface of Mars. The creatures evolving in that liquid vastness have followed evolutionary pathways, so divergent from terrestrial life that they occasionally appear more alien than our imagined extraterrestrials. The physical processes shaping oceanic environments operate at scales and timeframes that transcend direct human perception, creating patterns visible only through specialized instruments or satellite imagery. And somewhere in that darkness, in the crushing depths where light has never penetrated, new mysteries form continuously, waiting for the day human technology or understanding might finally illuminate their existence. So as you drift towards sleep, remember that beneath the waves covering 70% of our planet lies a world as mysterious now as when humans first gazed upon the sea, a realm of endless night where the truly unknown still thrives.